हेलो डियर स्टूडेंट्स, गुड इवनिंग, वेलकम टू एग्जाम दोस्त। कैसे हैं आप सभी लोग? तो कनेक्ट हो जाएंगे जल्दी से। और आज ये हम इस सेशन में यहाँ पर फिर से साथ में, जिसमें फिर से हम इलेक्ट्रिक इंजीनियरिंग सर्विसेज एग्जामिनेशन के कम्युनिकेशन के PYQs डिस्कस करेंगे। तो एक बार कंफर्म कर लेंगे आपको मेरी ऑडियो वीडियो सारी चीज़ें क्लियर हैं? ओके, सो आई होप ऑडियो वीडियो इज़ परफेक्टली क्लियर। तो चलिए स्टार्ट करते हैं सेशन को। बाइलिंगुअल सेशन होगा हमारा ये, और हिंदी इंग्लिश मीडियम दोनों ही स्टूडेंट्स इसके बेनिफिट्स ले सकते हैं। तो इससे पहले सेशन शुरू करें, आपके लिए जस्ट इन्फॉर्मेशन शेयर कर दूं मैं कि जो गेट 2026 और 27 के बैचेस हैं, उन सभी पर आप 30% फ्लैट वेवर ऑप्ट कर सकते हैं। यूज़ करना आपको कोड EB30, और इससे आप संकल्प 2.0 जो डबल ई बैच है वो 16,800 प्लस GST में बस आप अवेल कर सकते हैं, जो कि डबल ई का बैच है। और नीव बैच जो 2027 के लिए एस्पिरेंट्स के लिए है, वो आप 26,600 में ऑप्ट कर सकते हैं। के साथ अगर आप गेट एंड ESE दोनों की प्रिपरेशन कर रहे हैं, तो यहाँ पर आप 28 अप्रैल से बैच शुरू हो गया है, और इसमें लाइव प्लस रिकॉर्डेड अगर आपको लेक्चर्स चाहिए तो आप ओनली एट ₹18,200 प्लस GST में ऑप्ट कर सकते हैं। और अगर आप रिकॉर्डेड बैच चाहते हैं तो 10,500 प्लस GST में आप ये कोर्स अवेल कर सकते हैं। कोड यूज़ करना आपको EB30। सो लेट्स गेट स्टार्टेड विद द क्वेश्चंस। तो सबसे पहले तो आप लोगों को पेन पेपर के साथ यहाँ पर रहना है, ठीक है? क्योंकि अगर आप देखें तो ESE के जो क्वेश्चंस होते हैं वो यहाँ पर मैं आपको ऑलमोस्ट 2 मिनट से एक क्वेश्चन पढ़ लूँगा, लेकिन आप 30 to 40 सेकेंड्स में आप उसको सॉल्व कर सकते हैं। तो इससे पहले कि मेरा ऑप्शन आए, आपका ऑप्शन यहाँ पर हमें कमेंट सेक्शन में दिख जाना चाहिए। तो सभी लोग बता देंगे, रेडी हैं आप लोग? तो स्टार्ट करेंगे फिर क्वेश्चंस। ओके, सो लेट्स स्टार्टिंग विद द क्वेश्चंस। द फर्स्ट क्वेश्चन इज, for an amplitude modulated double sideband full carrier wave, a peak unmodulated carrier voltage VC equals to 10 volt, a load resistance RL equals to 10 ohm, and a modulation coefficient M equals to 1. What is the total power of modulated wave? What we are having here in this question, we have given that the carrier voltage, that is VC, you have given carrier voltage VC is equals to 10 volt. Then you are having load resistance RL, that is equals to 10 ohms, and modulation index M is equals to 1. So for total transmitted power, what formula we have to use? You know that total transmitted power PT is equals to PC times 1 plus M square by 2 for amplitude modulated wave. And if we have to calculate PC, so if you are having the value of load resistance, then you are going to calculate it by using PC is equals to VC square upon 2R. So PC is going to be what? VC, we are having voltage of carrier signal, that is 10 volt, so it will be 100 divided by twice of RL is given as 10 ohms, so it is 5 watt. So as soon as you have calculated the power, carrier power PC, so just substitute that power in this equation, and all other variables are known, so you can find the total transmitted power, that is going to be 5 times, it is 5 into 1 plus modulation index is 1, so it is going to be 1 by 2, that is equals to 5 into 1.5, that is equals to 7.5 watt, that is equals to 7.5 watt, and accordingly option A is correct. So I hope all of you are able to understand the solution, and you must be answering the question in comment section if you are able to solve the question. So try to solve every question what we are going to take. So the next opportunity for you is, it is in question 2. In an AM commercial broadcast receiver is operating in a frequency band of 535 kilohertz to 1605 kilohertz. So in general, if you see, the AM band is considered to be 540 kilohertz to 1650 kilohertz. It is normal AM band. In commercial, normally use 535 kilohertz to 1605 kilohertz. So it is given with an input filter factor of 54. Input filter factor is nothing but the quality factor of the filter, that is Q. So what you are having here is band, frequency band that you are using is from 535 kilohertz to 1605 kilohertz. and with this you are having quality factor Q is equals to 54. So now what is being asked in this question is, what are the bandwidths at the low and high ends of RF spectrums? Low and high ends. What does it mean? You are having the minimum frequency, that is 535 kilohertz. So it is the lower end, whereas it is the highest frequency 1605 kilohertz, which will be considered as the high ends of RF spectrum. So you know that the relation between quality factor and bandwidth, that is Q is equals to resonant frequency upon bandwidth. It is a basic formula that you must be aware of. So if we have to calculate bandwidth, then you can use this relation, and we can calculate bandwidth by using bandwidth is equals to resonant frequency upon quality factor. So in case of lower end, the resonant frequency is going to be 535 kilohertz, as well as for higher end, the resonant frequency you will have to take is 1605 kilohertz. So you just have to calculate these two values, that is bandwidth at lower end of RF spectrum. So it is going to be FR is 535 kilohertz divided by 54, and bandwidth at higher end, it is going to be this highest value of frequency, that is 1605 kilohertz divided by 54. You just have to calculate these two values, and if you calculate these, so what you are going to get is 535 divided by 54, the value is 9.907 kilohertz. If you see the options, then option is having two values for lower end frequency bandwidth, either 10 kilohertz or 100 kilohertz. So you will be taking the nearest option to the correct one. So it is going to be 10 kilohertz. It is nearest to 10 kilohertz. And at the higher end, the bandwidth is going to be 1605 upon 54, which is going to be 29.72 kilohertz. 29.72 kilohertz. And accordingly, 10 and 29 will be the correct option. So option C is correct for this question. I hope you all must be able to understand the solution. Whenever you have any doubt, then please let me know. तो दोनों ही लैंग्वेजेस में आप कंफर्टेबल होंगे, हिंदी इंग्लिश, क्योंकि ये बेसिक इंग्लिश ही हम यूज़ कर रहे हैं, तो इसलिए आप जहाँ पर भी आपको अगर कुछ प्रॉब्लम होती है तो बिल्कुल आप बताएंगे. चलिए नेक्स्ट क्वेश्चन देखते हैं. व्हाट इज द नेट बेस बैंड बैंडविड्थ इन फ्रीक्वेंसी डिवीजन मल्टीप्लेक्सिंग. देखिए, जब हम फ्रीक्वेंसी डिवीजन मल्टीप्लेक्सिंग करते हैं तो क्या करते हैं, आप एक ही चैनल को यूज़ करते हैं, डिफरेंट कैरियर्स के साथ आप अलग अलग सिग्नल्स को मॉड्यूलेट करके ट्रांसमिट करते हैं. तो अगर आपके पास मान लीजिए ये हमारी टोटल बैंडविड्थ है, अगर ये हमारे पास टोटल बैंडविड्थ है, तो जितने भी आपके कैरियर सिग्नल्स आप लेंगे अलग अलग मैसेजेस को मॉड्यूलेट करने के लिए, तो जिस बेस बैंड सिग्नल को आपने जिस कैरियर के साथ मॉड्यूलेट किया वो उस कैरियर फ्रीक्वेंसी पर जाकर सेंटर्ड होगा. ठीक है, तो अगर मान लीजिए आपका एक जो बेस बैंड स्पेक्ट्रम है वो एक इस कैरियर फ्रीक्वेंसी पर मॉड्यूलेट ये सेंटर्ड है, लेट्स से इट इज FC1. दूसरी, अब हम हर दो स्पेक्ट्रम्स के बीच में कुछ गार्ड बैंड रखेंगे जिससे कि ओवरलैपिंग ना हो. तो मान लीजिए कि नेक्स्ट हमारा स्पेक्ट्रम दूसरी कैरियर फ्रीक्वेंसी पर सेंटर्ड है, ये FC2. तो इस तरह से जितने भी आपने कैरियर्स यूज़ किए, जितने सिग्नल्स को एक साथ आपको एक ही चैनल को यूज़ करके ट्रांसमिट करना है, तो टोटल बैंडविड्थ अगर आप कंसिडर करते हैं तो टोटल बैंडविड्थ के लिए हर एक इंडिविजुअल मैसेज सिग्नल की बैंडविड्थ ऐड करते जाएंगे, और प्लस ये जो गार्ड बैंड आपने लिया है, दो चैनल्स के बीच में जो दो सिग्नल्स के बीच में इंटरफेरेंस ना हो, तो ये आपने गार्ड बैंड लिया हुआ. तो इसलिए टोटल जो नेट बैंडविड्थ होती है फ्रीक्वेंसी डिवीजन मल्टीप्लेक्सिंग में, वो किसके बराबर होगी, जितने भी बेस बैंड सिग्नल्स हैं उन सभी की बैंडविड्थ प्लस जो नंबर ऑफ गार्ड बैंड्स हैं उनकी टोटल बैंडविड्थ. एंड अकॉर्डिंगली इफ यू सी इट इज द सम ऑफ द मॉड्यूलेटेड मैसेज बैंडविड्थ एंड द गार्ड बैंड्स, इट इज द करेक्ट ऑप्शन. नेक्स्ट ऑप्शंस आप पढ़ सकते हैं बाकी ऑप्शंस को भी, जैसे सेकंड ऑप्शन इट इज द प्रोडक्ट ऑफ द मॉड्यूलेटेड मैसेज बैंडविड्थ एंड द गार्ड बैंड्स. प्रोडक्ट नेवर, इट इज गोइंग टू बी द प्रोडक्ट ऑफ टू बैंडविड्थ. ठीक है, इट इज द वैल्यू ऑब्टेन्ड बाय सब्ट्रैक्टिंग मॉड्यूलेटेड बैंडविड्थ. सब्ट्रैक्टिंग इज नॉट करेक्ट. It is the product is not correct. So option A is correct for this. given question. Next it is given to be, let x of t is equals to 5 cos 50t plus sin 5t. Its instantaneous frequency in radians per second at t is equals to 0 seconds is. So what you can infer from this given question, it is of the form a cos omega ct plus phi. So it is the total phase angle of the given signal x of t. So if you have to find the instantaneous frequency, then to find frequency, what you all have to do is, you just have to differentiate the given phase angle. You know that frequency is equals to d by dt of phase angle. D by dt of phase angle. So it is the total phase angle of the given signal x of t. So if you have to find the instantaneous frequency, then omega I, we can write it as d by dt of theta I of t, and if it is the function of time, so it is going to be d by dt of phase angle you are having here is 50t plus sin 5t. So it is going to be 50 and plus 5 cos 5t. So it is you have obtained instantaneous frequency. Why you are naming it as instantaneous frequency? Because it is function of time and at every instant of time the value will be different. So if you have to take the value at t is equals to 0 seconds, therefore it is omega I t. Therefore if you have to calculate omega I at t is equals to 0 seconds, so you just have to put t is equals to 0 in the given equation. So it is going to be 5 cos 0 is 1. Therefore 50 plus 5, that is equals to 55 radians per second. So if it is asked in radians per second, then you can directly take the value as 55. But if it would be asked in hertz, then you must have to be divided by 2 pi. So accordingly option C is correct. Any problem? Yes, 29.72 Ravi is absolutely correct for the previous one. Next is, an AM wave uses a 225 volt 500 hertz modulating frequency and has a modulation index of 50. The deviation is, it is about the FM wave. So before solving further few questions, I just want to discuss some of the key concepts from FM and AM waves. FM and PM modulation, phase and frequency modulation. So let's say if you are having carrier signal, we are just discussing basics of FM and PM. It is very important because you are going to have next 10 to 15 questions on FM and PM, phase modulation and frequency modulation. So you just need to know all the facts. That is, let's say whenever you talk about frequency modulation, it means you are going to change frequency of the carrier signal in accordance with the intelligence of baseband signal or modulating signal what you have to transmit. So if you say that the carrier signal Vc of t is AC cos omega ct plus theta. Let's say it is your carrier signal. In general theta is equals to 0. तो हम इसको ले लेते हैं लेट्स से AC cos omega ct. ठीक है, यहाँ पर अगर हम इसको फाई नाम दे दें, ये जो हमारा फेज एडवांस या डिले है, तो नॉर्मली हम AC cos omega ct के हमारे पास ये कैरियर सिग्नल है जिसकी हमें क्या चेंज करनी है. अगर हम फ्रीक्वेंसी मॉड्यूलेशन करना चाहते हैं तो हम अपने जिस सिग्नल को हमें ट्रांसमिट करना है उस xt के अकॉर्डिंग हम इसकी फ्रीक्वेंसी ओमेगा c को चेंज करेंगे. ये ओमेगा c क्या है? फ्रीक्वेंसी है. टोटल ओमेगा ct क्या है? फेज एंगल. तो इन फ्रीक्वेंसी मॉड्यूलेशन अगर हम बात करें किसकी? फ्रीक्वेंसी मॉड्यूलेशन. ठीक है, तो यहाँ पर अगर आप देखें ये हमारा टोटल क्या है? टोटल ये फेज एंगल. अगर हम यहाँ पर इंस्टेंटेनियस फ्रीक्वेंसी की बात करें, फ्रीक्वेंसी मॉड्यूलेशन की जब हम बात करते हैं तो हम इस कैरियर की अभी जो फ्रीक्वेंसी ओमेगा सी है इसको हम चेंज करेंगे किसके अकॉर्डिंग? अपने मॉड्यूलेटिंग सिग्नल या बेसबैंड सिग्नल के अकॉर्डिंग. और तब जो हमें फ्रीक्वेंसी मिलेगी उसको हम नाम दे रहे हैं इंस्टेंटेनियस फ्रीक्वेंसी ऑफ मॉड्यूलेटेड वेव, जिसको हमने ओमेगा आई नाम दिया. तो ओमेगा आई हमें कैसे मिलेगा? जो एक्चुअल कैरियर फ्रीक्वेंसी है उसको हम वेरी करेंगे kf इंटू एम ऑफ टी. एम ऑफ टी जिस सिग्नल को हमें ट्रांसमिट करना है यही हमारा बेसबैंड सिग्नल होता है. ठीक है, ये सभी चीज़ें आप जानते हैं. जहाँ पर हम ये जो kf लिख रहे हैं, इट इज़ फ्रीक्वेंसी सेंसिटिविटी. फ्रीक्वेंसी सेंसिटिविटी। अगर आप इसकी यूनिट देखें तो इसकी यूनिट होती है या तो रेडियंस पर वोल्ट पर सेकेंड, रेडियंस पर सेकेंड पर वोल्ट, और अगर आप रेडियंस पर सेकेंड में नहीं लेकर अगर आप चाहें तो इसको हर्ट्ज पर वोल्ट में भी ले सकते हैं, तो दोनों ही यूनिट्स आप यूज करते हैं। तो ये हमारे पास क्या इंस्टेंटेनियस फ्रीक्वेंसी ऑफ द मॉड्यूलेटेड वेव। अब अगर इंस्टेंटेनियस फ्रीक्वेंसी आ गई, ये भी टाइम का फंक्शन होगा कुछ, क्योंकि यहाँ पर आपको एम ऑफ टी दिख रहा है, ये टाइम का फंक्शन होगा। तो ओवरऑल किस इंस्टेंट पर कैरियर की फ्रीक्वेंसी में कितना चेंज आया वो डिपेंड करता है कि आपकी मैसेज सिग्नल की क्या वैल्यू थी। अगर ये ओमेगा आई ऑफ टी मिल गया, मतलब ये आपको अगर फ्रीक्वेंसी मिल गई, तो अभी अभी आपने थोड़ी देर पहले लिखा कि फेज और फ्रीक्वेंसी के बीच का रिलेशन क्या है। फ्रीक्वेंसी फेज को डिफरेंशिएट करने से मिलती है, तो फेज एंगल कैसे मिलेगा, ये फेज एंगल आपको कैसे मिलेगा जब आप फ्रीक्वेंसी को इंटीग्रेट करेंगे विद रिस्पेक्ट टू टाइम। ठीक है, तो अगर आपके पास यहाँ पर इंस्टेंटेनियस क्या आ गया है, अगर आपके पास यहाँ पर इंस्टेंटेनियस फ्रीक्वेंसी, देयरफॉर इंस्टेंटेनियस फेज एंगल of modulated carrier is what theta I of t is integration from 0 to t omega I of t dt, that is equals to integration 0 to t omega c plus kf into m of t dt. So this omega c is constant with respect to time. So if you are going to integrate, then it is going to be omega ct, and plus kf is constant, so you can take it outside the integration from 0 to t. It is going to be m of t dt. So it is the total instantaneous phase angle of the carrier. So earlier the carrier had a phase angle of omega ct only. Now if you have changed this carrier in accordance with the intelligence of your baseband signal, now the instantaneous phase angle theta I of t is this. Therefore, hence equation of FM modulated wave. So equation of FM modulated wave is x FM of t. Let's say if you are writing x FM of t, so it will be AC cos theta I of t, as previously it was AC cos omega ct, that is theta of t. So you have changed this theta of t to theta I of t, that is going to be omega ct plus kf times this integrated value of message signal m of t. So now if you substitute the value of theta I of t, then you will be getting x fm of t as AC cos of, at the place of theta I of t you can write omega ct plus kf times integration from 0 to t m of t dt. So it is equation for the frequency modulated wave. Now if you have to generate a phase modulated wave, then you can directly change this phase angle according to the baseband signal. So if you are going to generate a phase modulated wave, phase modulation, carrier signal is, let's say v of t is AC cos omega ct as well. कैरियर वही है। अब हम इस टोटल फेज एंगल को डायरेक्टली चेंज करेंगे विद रिस्पेक्ट टू मैसेज सिग्नल। पहले हम इस टोटल फेज एंगल को चेंज नहीं कर रहे थे, हमने पहले सिर्फ फ्रीक्वेंसी को चेंज किया फ्रीक्वेंसी मॉड्यूलेशन में, उसके बाद टोटल फेज एंगल हमने इंस्टेंटेनियस कैलकुलेट करके उसको सब्स्टिट्यूट किया। अब यहाँ पर अगर आप देखें तो इंस्टेंटेनियस फेज एंगल, इंस्टेंटेनियस फेज of modulated carrier, अब इसको अगर हमने थीटा आई ऑफ टी नाम दिया, तो यहाँ पर थीटा आई ऑफ टी, पहले जो हमारा थीटा ऑफ टी था ये ओमेगा सी टी, इसमें डायरेक्टली हम एम ऑफ टी के अकॉर्डिंग इसको चेंज कर सकते हैं। अब यहाँ पर हमने जैसे वहाँ के एफ लिया था, यहाँ पर हम क्या लेते हैं, के पी लेते हैं, फेज सेंसिटिविटी। यहाँ पर हमने जो लिया है के पी, इट इज फेज सेंसिटिविटी कांस्टेंट, और इसकी जो यूनिट होती है दैट इज इन रेडियंस पर वोल्ट। तो अब ये डायरेक्टली आपको थीटा आई ऑफ टी मिल गया। तो यहाँ से इस थीटा, पहले जो हमारा फेज एंगल सिर्फ ओमेगा सी टी था, वो फेज एंगल कितना हो गया, ओमेगा सी टी प्लस के पी इंटू एम ऑफ टी। देयरफॉर एक्सप्रेशन फॉर, या आप लिखें इक्वेशन फॉर फेज मॉड्यूलेटेड वेव, तो ये डायरेक्टली आपको क्या मिल जाएगा, एक्स पी एम ऑफ टी इज इक्वल्स टू, अगेन इट इज ए सी कॉस थीटा आई ऑफ टी। अब यहाँ पर थीटा आई टी की वैल्यू पुट कर दीजिए, दैट इज ए सी कॉस ऑफ ओमेगा सी टी प्लस के पी टाइम्स एम ऑफ टी। तो ये क्या आ गया हमारे पास, फेज मॉड्यूलेटेड वेव की इक्वेशन आ गई। अगर आप इन दोनों इक्वेशंस को कंपेयर करें, ठीक है, 5 मिनट्स आपको और देखना है। यहाँ पर हम नैरो बैंड फ्रीक्वेंसी बैंड की इक्वेशंस लिखेंगे, उसके बाद सारे क्वेश्चंस आप देखेंगे यहीं से आपको सॉल्व होते चले जाएंगे। तो हमने लिखा है फेज फ्रीक्वेंसी मॉड्यूलेशन, ये वैल्यू क्या थी, ए सी कॉस ऑफ ओमेगा सी टी प्लस के एफ इंटू इंटीग्रेशन ऑफ एम ऑफ टी डी टी। और हमने लिखी है इक्वेशन फेज मॉड्यूलेटेड वेव के लिए, ये इक्वेशन है हमारे पास, ए सी कॉस ऑफ ओमेगा सी टी प्लस के पी टाइम्स एम ऑफ टी। अगर आप इन दोनों इक्वेशंस को कंपेयर करें, ठीक है, अगर आप देखें, अगर मान लीजिए हम यहाँ पर दो चीज़ें करते हैं, मान लीजिए कि हमने ये एम ऑफ टी सिग्नल लिया, हमने एम ऑफ टी सिग्नल लिया, ठीक है। अगर हम इसको पहले एक डिफरेंशिएटर से पास कर दें, एम ऑफ टी को डिफरेंशिएटर से पास कर दे, तो हमारे पास क्या जनरेट होगा, डी बाई डी टी ऑफ एम टी सिग्नल आएगा। अब इस डी बाई डी टी ऑफ एम टी सिग्नल का को अगर हम यहाँ पर, अगर हम इसका फ्रीक्वेंसी मॉड्यूलेशन कर दें, अगर हम इसका फ्रीक्वेंसी मॉड्यूलेशन कर दें, जैसे हम जब सिग्नल एम ऑफ टी लेकर के उसका फ्रीक्वेंसी मॉड्यूलेशन करते हैं, तो ये हमारे पास इक्वेशन आती है। अब जब एम टी की जगह पर डी बाई डी टी ऑफ एम टी है, उस पर यही ऑपरेशन परफॉर्म करेंगे, तो यहाँ एम टी को चेंज कर देंगे डी बाई डी टी ऑफ एम टी से, तो हमें क्या मिलेगा, ये इंटीग्रेशन और डिफरेंशिएशन कैंसिल हो जाएगा, और यहाँ पर हमें जो चीज़ मिलेगी वो मिलेगी ए सी कॉस ऑफ ओमेगा सी टी प्लस के एफ इंटू एम टी, जो कि अगर आप देखें ये भी एक कांस्टेंट है, ये भी एक कांस्टेंट है। अगर आप देखें तो ये जो इक्वेशन है, ये हमें क्या दे रहा है, ये हमें दे रहा है फ्रीक्वेंसी मॉड्यूलेशन, ये हमें दे रहा है फेज मॉड्यूलेशन। अगर हम एक मैसेज सिग्नल ले एम टी, उसको पहले डिफरेंशिएट करके उसका फ्रीक्वेंसी मॉड्यूलेशन कर दे, तो हमें क्या मिलेगी, फेज मॉड्यूलेटेड वेव की इक्वेशन मिलेगी। अगर हम यहीं पर एम ऑफ टी एक सिग्नल लें, और इस सिग्नल को अगर हम पहले एक इंटीग्रेटर से पास कर दें, अगर हम इसको पहले एक इंटीग्रेटर से पास कर दें, और इंटीग्रेट करने के बाद इस बेस बैंड सिग्नल को हम अगर फेज मॉड्यूलेटर से पास करें, अगर हम यहाँ पर इसका फेज मॉड्यूलेशन कर दें, फेज मॉड्यूलेशन मतलब ये चीज़, बस सारी चीज़ें सेम है। एम को हमने किससे रिप्लेस कर दिया, अब यहाँ पर एम की जगह पर हमारे पास वैल्यू आ गई 0 टू टी एम ऑफ टी डी टी। तो अगर हमने यहाँ एम को अगर आप रिप्लेस कर देंगे एम के इंटीग्रेशन से, तो यहाँ आपको क्या चीज़ मिलेगी, यहाँ आपको वैल्यू मिलेगी ए सी कॉस ऑफ ओमेगा सी टी प्लस के पी टाइम्स 0 टू टी एम ऑफ टी डी टी। जिसको देखकर आप क्या समझ रहे हैं, ये कैसी इक्वेशन, एग्जैक्टली जैसी फेज मॉड्यूलेशन के केस में इक्वेशन आती है। मतलब अगर आप एक सिग्नल को लेकर पहले उसको इंटीग्रेट कर लें बेस बैंड सिग्नल को, उसके बाद फेज मॉड्यूलेशन परफॉर्म करें, तो अल्टीमेटली आप क्या परफॉर्म कर रहे हैं, उसका फ्रीक्वेंसी मॉड्यूलेशन आपको यहाँ पर परफॉर्म होता हुआ दिख रहा है। तो ये दो चीज़ें आप समझ गए। अब अभी जो हमने लिखा, ये फेज मॉड्यूलेशन जो हमने, ये जो फ्रीक्वेंसी मॉड्यूलेशन हमने किया, सारी चीज़ इसमें हम यही रखें। अब एम की जगह पर अगर हम कोई साइनसॉइडल फंक्शन ले लें, क्योंकि नॉर्मली आप जिस बेस बैंड सिग्नल को ट्रांसमिट करते हैं वो हम एक साइनसॉइडल सिग्नल किसी फ्रीक्वेंसी के ट्रांसमिट करते हैं अगर, तो साइनसॉइडल फ्रीक्वेंसी मॉड्यूलेशन में क्या दिखेगा आपको। सो इफ वी नेक्स्ट सी साइनसॉइडल frequency modulation. So carrier, is your carrier VC of t is same, that is AC cos omega ct. Now message signal m of t we are going to take is am cos omega mt. So in the previous one, if you say the instantaneous phase and frequency of the modulated carrier, instantaneous frequency of modulated carrier, then it is going to be what? Omega c frequency of carrier plus kf times m of t. And at the place of m of t, now it is your m of t, that is am cos omega mt. What we have performed earlier, I am just repeating that, but at the place of mt, now I am using the sinusoidal function am cos omega mt. So now if you see this factor kf into am, this factor kf into am is said to be del omega, that is frequency, maximum frequency deviation. Maximum frequency deviation. And if this factor kf is in radians per second per volt, then it is going to be del omega. If you take this factor kf in terms of hertz per volt, then this factor will be giving you kf into m will be del f. So it is depending on whether you have to calculate del f or del omega. If you have to calculate maximum frequency deviation in radians per second, then you will be using kf in radians per second per volt. If you have to find deviation in terms of hertz, then you will be taking kf in terms of hertz per volt. So it is kf into m is known as maximum frequency deviation del omega. Now it is instantaneous frequency, therefore we have to find instantaneous phase angle using integrating this frequency. Integration 0 to t this omega I of t dt, which is going to give you omega ct. If you are going to integrate this factor with respect to t, then it will be omega ct plus this, it is equals to omega c plus del omega into cos omega mt. So now if you are going to integrate it, this factor, then omega c will result into omega ct, and plus this del omega is constant, and integration of this cos omega mt will give you sine omega mt upon omega m. So you can write it like del omega upon omega m sine omega mt. And you are going to define this term del omega upon omega m as your modulation index of frequency modulation. It is known as modulation index, which is equals to beta. So it is equals to omega ct plus beta sine omega mt. It is your instantaneous phase angle of modulated carrier. So the final frequency modulated wave equation will be AC cos theta I of t. You just have to replace this omega ct by that term omega ct plus beta sine omega mt. Therefore, finally you will be getting equation of frequency modulated carrier or wave, that is x fm of t is going to be AC cos theta I of t, that is AC cos of omega ct plus beta sine omega mt. It is the basic expression for frequency modulated wave. Now, depending on the values of beta, you have two types of frequency modulation. Case 1, narrow band frequency modulation. If beta is very small. Narrow band frequency modulation. If you break, so now till now what you have already obtained is you have two formula. For modulation index, it will be del omega upon omega m, or it is equals to either you write del omega upon omega m, or del omega can be written as 2 pi del f upon omega m can be written as 2 pi omega m del m fm. Therefore it can also be taken as del f upon fm. As it is the ratio, so ratio will be same for del f upon fm and del omega upon omega. So it is one formula which is very important. Another formula is this, that is maximum frequency deviation del omega is kf into m. These two are very important formulas. Now if you see here, if beta is very small, if you expand this expression using the concept of cos of a plus b, then what you are going to get is x fm of t. It is AC times cos of a plus b is cos a cos b, that is cos omega ct into cos of beta sine omega mt and minus sine A sine B, that is sine omega ct into sine of beta sine omega mt. Now, what you know from the trigonometric identity is, if you are going to take limit theta tending to 0 sine theta, then it is approximately equals to theta. And if you take limit theta tending to 0 cos theta, then you know that the value is approximately equals to what? 1. So if you see here, if beta is very small, then this beta sine omega mt considered to be negligibly small, that is tending to 0. So this factor cos theta is equals to approximately 1, and this term sine theta is approximately equals to theta only, that is beta sine omega mt. I hope it is clear. So now finally, as a frequency modulation in case of narrow band, you are going to get X NBFM, narrow band frequency modulation wave. It is going to be AC cos omega ct, which is nothing but your carrier, and minus it is AC into beta times sine omega ct sine omega mt. Now if you further simplify it using 2 sine A sine B, then it is going to get you are going to get that is equals to AC cos omega ct minus AC beta by 2 cos of omega c minus omega mt and plus AC beta by 2 cos of omega c plus omega mt. So it is very important, it is the equation for narrow band frequency modulation, X narrow band frequency modulation. So what you can see from here is, it is the carrier signal which is present itself, and you are having 2 sidebands. The carrier and upper sidebands are in phase because both is having positive sign, while the lower sideband is having negative sign. So carrier and you must be noting this point, carrier and upper sidebands are in phase and lower sideband is out of phase by 180 degrees. And both the sidebands has an amplitude of AC times beta by 2. These two facts must be noted from this equation of narrow band frequency modulation, right? Now if you move to the wideband frequency modulation, it is the last point that is going to discuss in this theory portion, wideband frequency modulation. So from this equation only, XFM of t, what we have already obtained is AC cos omega ct plus beta sine omega mt. We have first expanded it into AC times cos of omega ct into cos of beta sine omega mt and minus sine of omega ct into sine of beta sine omega mt. If beta is not too small, then now these two signals are going to be periodic in nature. Earlier, if beta was very small, then we have taken it as tending to 0. Therefore, these values are cos 0 nearly equals to 1 and sine theta for theta tending to 0 is nearly equals to theta. But now these two signals, if you see here, you can write these two signals. Now these are periodic with omega m, frequency omega m, if beta is not too small, and that's why final expression, I'm just writing the final expression as we have to save time. So the final expression for frequency modulation in case of wideband, X wideband FM of t, it is going to be AC times J0 beta cos omega ct minus AC into AC, you can take common from all the expression. So it will be J1 beta into cos of omega c minus omega m into t minus of, it is cos of omega c plus omega m. For odd number, if you are taking J1, then sign will be minus, and here will be omega c minus 1 omega m plus 1 omega. Next factor will be with plus sign J2 beta into cos of, here you will be having cos of omega c minus twice of omega m, and the intermediate sign will be positive in this case, and cos of omega c plus twice of omega. Similarly, we have to proceed further. That is, for the next value, the odd number will be J3 times beta, J3 of beta. It is Bessel function of first kind. So the wideband frequency modulation is given in terms of Bessel function, and the expression is something like this. It is cos of, now it is omega c minus thrice of omega m plus and minus of cos of omega c plus thrice of omega m, and so on. Next value will be with plus sign. Here it is minus sign. So what you can observe by this expression of wideband frequency modulation, and this from this narrowband frequency modulation. The narrowband frequency modulation has only two sidebands, and therefore if you see here, the minimum frequency is omega c minus omega m, maximum frequency is omega c plus 2 plus omega m. So the total range of frequencies you are going to get is twice of omega. If you subtract from this frequency, if you subtract this frequency, it is omega c minus omega m into t. So you are going to get twice of omega. So I am just writing 2 points for narrowband frequency modulation. Carrier and USB are in phase, and LSB is out of phase. Out of phase. First point you have to remember. And there are only two sidebands. Bandwidth required is omega c plus omega m minus of omega c minus omega m, that is equals to twice of omega. Either you understand by this, or you can also see like this. That is, you are having three cosine functions. So if you will be plotting the spectrum of this function, then for every cosine function you have to take two impulses at the frequencies of that cosine function. So there will be two impulses at plus minus omega c, two impulses at plus minus omega c minus omega m, and two impulses at plus minus omega c plus omega. So if I plot only the positive side of spectrum, then you are going to have one impulse at omega c frequency, one impulse at omega c plus omega m frequency, and one at omega c minus omega m frequency. I have just plotted it for positive frequencies. Similar spectrum will be at the negative side as well. For this, it will be AC times pi, because for this cosine function, amplitude is AC, and for Fourier transform of cos omega ct, you will be taking pi times del of omega minus omega c del of omega plus omega c. So AC times pi. And for these two functions, if you see, amplitude is AC times beta by 2. So there will be AC beta pi by 2. So if you see here, lower sideband will have negative sign. So if you plot it correctly, then this will be negative side. It will be minus AC beta pi by 2, and it will be plus AC beta pi by 2. AC beta pi by 2. Therefore, the range of frequencies is equals to twice of omega m because we have only two sidebands. But in case of wideband, if you now see, from here if you see, there is a carrier signal which is present and there are infinite number of sidebands. In the spectrum, if you see, the impulses will be at omega c minus omega m, omega c plus omega m, omega c minus twice of omega m, omega c plus twice of omega, and so on. If you plot the spectrum, I am just plotting it for positive frequencies. So we will be having an impulse at omega c, then there will be impulses at omega c plus minus omega m, omega c minus omega m, omega c plus omega m. I'm not considering the positive or negative sign of impulses because I just have to show you how the spectrum is looking like. Okay, so next spectrum will be, there will be two impulses at omega c plus minus twice of omega m. There will be a one impulse at omega c plus twice omega m, omega c minus twice omega m. Then again there will be two impulses at frequencies omega c plus minus 3 omega m. Here it is omega c plus 3 omega m. Again there will be omega c minus 3 omega m, and so on. There will be infinite number of sidebands. In case of narrow band frequency wideband frequency modulation. So in wideband frequency modulation, these are very important points. What I am going to write here is, first, there are infinite number of sidebands, right? So at the receiver end, how many sidebands will be present depends on the value of beta. As you increase the value of beta, the number of sidebands received at significantly at receiver end will be increasing. Next is modulation index beta determines the number of significant sidebands. As beta increases, number of sidebands and hence required bandwidth also increases. Because if beta will be increasing, then significant values of sidebands will be increasing, and as many sidebands you have to recover, you have to take that many value of bandwidth. So beta decides how many sidebands will be significant amplitudes and power at the receiver end. While the total power is always constant, transmitted total power is always constant, that is equals to carrier power. In frequency modulation, total transmitted power is always equal to the total carrier power. Next, third is, if you see Carson's bandwidth formula. Carson's bandwidth formula. It is again very important one. That is, bandwidth is equals to twice of beta plus 1 into omega. If we calculate in radians per second, or if you have to calculate in hertz, then at the place of omega m you will be taking fm. If you substitute beta is equals to del omega upon omega m, then it will be twice of del omega plus omega. Omega m and omega m will be cancelled. So either you can take this or you can take twice of beta plus 1 fm, and it will be twice of del f plus fm if you are going to take it in hertz. It is in radians per second, it is in hertz. So now I have completed with the theory portion, and now you are going to answer all the questions that are going to come within seconds. What you have to keep in mind, in wideband frequency modulation there will be infinite number of sidebands. Carrier beta decides at the receiver end how many sidebands will have significant amplitudes. And the third and one more important point is, here you are having carrier signal as well, but this carrier can vanish you can suppress this carrier if this J0 or beta function becomes 0. If J0 or beta is 0, then this product is 0. And it can happen for several selected or you can say particular values of beta. If you see the graph of J0 beta with respect to beta, if you plot graph of J0 beta with respect to beta, so it is something like this. So at it is J0 beta with respect to beta. So it is value of beta is 2.4, 5.5, 8.6 and 11.8. These are some of the values of beta for which J0 of beta is equals to 0. So or we can write it is possible to suppress carrier or for the carrier to get vanished for some selected values of beta. It is possible to suppress carrier for some selected values of beta. So what are these values? These are either 2.4, 5.5, 8.6, 11.8. Several other values are also there, but these are common values that you must be keeping into your mind. So now you are completed with the theory portion, and now if you move towards the questions, then see how easily you can answer all the questions. First is FM wave uses 2 to 5 volts 500 Hz modulating frequency. So it is FM given to be FM is equals to 500 Hz and has a modulation index of 50 and beta is equals to 50. So you have to calculate frequency deviation. So what you know is frequency deviation beta is defined as either del omega upon omega m, or we have already seen that we can define it as del f upon fm as well. So if you are having beta m value of fm, then del f directly equals to, therefore frequency deviation del f is equals to beta times fm, and that is going to be beta value is given to be 50 and fm is 500 Hz. So it is going to be 25,000. So maximum frequency deviation is going to be 25,000 Hz, and accordingly option D is correct. So if you are having any doubt in the theory of FM, then please let me know. Yes, Ravi, it will get cancelled. Is everything clear till now? Because we have discussed very important concepts of frequency modulation and phase modulation in a single video in 10 minutes. So now if you take the next question is match list 1 with list 2, application select correct option. So in the previous previous session, what we have already discussed is the use of pre-emphasis and de-emphasis circuits. And we have already seen that pre-emphasis is done at the transmitter end, while the de-emphasis is done at the receiver end in case of frequency modulation. So pre-emphasis you just can take at FM transmitter, de-emphasis you can take at FM receiver. So for A there must be 4, so you are having two options as A equals to 4, and for D there must be 2. So A4 and D2 option is already clear, that is option C is correct, but still if you see other given parameters as well. So Armstrong method is the method of generation of frequency modulation, and it is considered to be an indirect method of frequency modulation generation. So it is frequency generator, Armstrong method. For B there must be option 3, and you can see here for B it is mentioning to be 3. And envelope detector, you know, it is a diode detector which is used for the demodulation of AM waves. So for this you will be selecting 1, and accordingly option for C it must be 1, so option C is correct for the given question. So you must be aware of all of these terms: pre-emphasis, de-emphasis, envelope detector, Armstrong method. It is very much important, it takes very importance in particularly for the ESE examination. Moving to the next question, which one of the following correctly describes the block diagram, block 1 and block 2 in the diagram given below? Now, if you see, I've already discussed in the theory section of phase and frequency modulation. What we have already taken is which kind of expression it is? AC cos omega ct plus kp times m of t. We are directly varying the total phase angle of carrier in accordance with our baseband signal m of t. Therefore, it is the expression for phase modulation. So if you have to obtain phase modulation, then what you all have to do is, first you have to differentiate the message signal d by dt, and then you have to perform frequency modulation on this signal. Then you are going to get the phase modulation. This is only what we have already discussed here. We have already discussed this point here. That is, if we take mt, first differentiate it, then pass it through a frequency modulation from frequency modulator, then we are going to get phase modulation. And accordingly, if you see which option is correct, you must be answering it just by observing the question. That is, first block is differentiator. So from C and D, there may be any one option correct. And the next block must be frequency modulator. Therefore, option D is correct for this question. Is it clear? Yes, Ravi is absolutely correct. Phase modulation equation is this. So moving to the next question. Next we are having we have to match the two columns, that is wideband FM AM, VSB AM, narrowband FM. So in ESE examination, there may be questions in which you are not able to understand all the 4 parameters given in one part, but you must be able to at least identify 1 or 2. So in options of ESE, if you see, they are kept very simple. They must be, if you are able to at least identify 2 of the correct options, then you will be able to solve this question as well. So if you see, we have already discussed this. VSB AM is used for video transmission of TV signals. So VSB AM will be TV video. So for D, there must be 3. So you just set C here. So from these two, any one option will be correct. Now, what you must be able to understand is for AM. So for AM, you know that for AM, AM is done in the medium broadcasting. That is from 535 kilohertz to 1605 kilohertz that you have already seen in the previous question. So for AM, there must be medium wave broadcast. So for C, there must be 5. For C, there must be 5. It means you can already select this correct option, that is going to be C. But still, if you see other options as well. So what we have already discussed is narrowband frequency modulation and wideband frequency modulation. So narrowband frequency modulation, we have seen it requires lesser bandwidth, and therefore this narrowband frequency modulation is used for TV audio signals. And for narrowband frequency modulation is used for mobile communication, and wideband frequency modulation, if you see, it is used for TV audio. And accordingly, for A, there must be 4. For B, narrowband frequency modulation must be 1, and accordingly option C is correct. So you must be able to take match all these 4 with the next column, that is wideband frequency modulation is used for TV audio. We have already seen for TV transmission. What we have discussed is audio and video. So for video and audio, we have already discussed this, that we use VSB AM, and for audio we use FM. Therefore, you just can remember these concepts, and you can take the correct option, and this is going to be option C, that is 4, 1, 5 and 3. If you are having any doubt, then please let me know. The next one is, which one of the following are the advantages of FM broadcasting over AM broadcasting? Can you answer this question? Yes, TV audio AM. Yes, Ravi, you are absolutely correct. So the next question is about the comparison of FM broadcasting over AM broadcasting. So better SNR ratio, signal to noise ratio, it is absolutely correct. FM is more immune to noise than FM. That is, better SN signal to noise ratio is possible. Not subject to signal fading, no. Frequency modulated waves are subjected to frequency signal fading. Next, power efficiency is superior. It is also correct. For FM, power efficiency is also superior. And demodulation is simpler. See, FM demodulators are way more complex than AM demodulators. Therefore, if you see Foster-Seeley discriminator or whatever frequency demodulators are there, they are way more complex than the AM demodulators. Therefore, it is not correct. So these two options are correct, that is 1 and 4, and accordingly 1 and 3, and accordingly option D is correct for this given question. So for question number 9, option D is correct. Next, with the increase in the transmission bandwidth, received signal power in AM and FM will respectively. Now, you can answer this question if you have watched this lecture from the starting, that is when we have discussed the theory portion of FM. What we have already discussed is, I have already written it for you, that is modulation index beta determines number of significant sidebands. As beta increases, number of sidebands and hence required bandwidth increases. So number of sidebands increases, it means received power will be increasing. That's what I have discussed with you. Therefore, in this question, if you see, we have to check with the increase in the transmission bandwidth. If beta is increased, then bandwidth will be increased in FM. And if bandwidth will increase, then received signal power in FM increases. But in AM, bandwidth is fixed to be twice of omega. Therefore, if you increase further the bandwidth, the two sidebands are located only in the range of twice of omega. There are no further sidebands outside that spectrum. Therefore, if you are going to increase further the bandwidth from twice of omega m to infinity, no other components are going to be included. Therefore, the total signal power received will not be changing. Therefore, in case of AM, the signal power will remain same in case of AM. And in case of FM, if you increase bandwidth, the number of sidebands will be increased and total received power will be increased. Therefore, option B is correct for this given question. Is it clear? Is it clear? Is every one of you getting all the points? Yes, Ravi, absolutely correct. D option for previous question. And for this question, option B is correct. Moving to the next question. Assertion and reasoning question is given as, first assertion is, bandwidth of angle modulated signal is infinite. It is absolutely correct. What we have already seen in case of wideband frequency modulation. There are infinite number of sidebands. Therefore, total bandwidth of FM is infinity. Angle modulation of a carrier results in the generation of an infinite number of sidebands. Yes, it is the correct reason as well for this given assertion. Why bandwidth in case of angle modulation is infinite? Because there are infinite number of sidebands. Therefore, you can say that this reasoning is correct for the given assertion, and therefore you are going to select option A for this question. For this question, option A is correct. Next, an angle modulated signal is described by the equation. What is the, you are having an equation. Now, if you see what we have discussed in frequency modulation, that is, we have written XFM of t. Frequency modulation and phase modulation both are considered to be case of angle modulation. There are two types of angle modulation, frequency modulation and phase modulation. So we have written for frequency modulation, it is given as AC cos of omega ct plus beta sine omega nt. Now, in this case, you are having two signals. So what we have seen is single tone frequency modulation. At the place of MT, I have taken only one signal of frequency omega m. If you are going to take more than one signal, that will be multi-tone frequency modulation, and then you will be having such kind of signal, that is such kind of modulated wave. So no need to go for further investigation. What you have to calculate is, what is the bandwidth of this modulated signal? So to find bandwidth, what you need is, you know that bandwidth is going to be what? It is going to be twice of beta plus 1 times omega. So there are two modulating signals, and one signal is having a frequency of 4000 pi radians per second. It is omega m1, and 2000 pi radians per second, it is your omega m2. So which one is bigger? Or we can see here, what is the maximum remodulating frequency? So it is 4000 pi radians per second. If we see here, overall omega m can be taken from these two as 4000 pi radians per second. That is equals to what? 2000 hertz. If you calculate in hertz, because all the options are given in hertz, so you have already seen that the value of omega m is 2000 hertz. That is 2 kilohertz. Now, if you are able to calculate beta only, then the question will get solved. So to find beta, what we have already discussed is beta is equals to, either we can take del f upon fm, or we can take del omega upon omega. So as we are having omega m as this, so it is what? It is your fm. Therefore, you can write fm is equals to 2000 hertz. So we are already having fm, and to calculate beta, we need to calculate del f upon fm. Fm is known, so you just have to calculate del f. If you have calculated del f, then using this formula we can find the bandwidth of the given waveform. So to find maximum frequency deviation, if it is the total phase angle, if you see here, total phase angle, total instantaneous phase angle, if you name it as theta I of t, then it is going to be this 2 pi fc. I am writing it as omega c. So it is omega ct. 2 pi fc is omega c. So it is omega ct plus 10 sine. If you write it as omega m1t, then you can write, otherwise you can put the value as 4000 pi t plus 5 sine 2000 pi t. If it is the phase angle, and if you have to find out the maximum frequency deviation from the carrier frequency, then what you have to do is, you just have to differentiate this phase angle. So to find instantaneous phase frequency in radians per second, if I am writing in terms of omega, it means I am going to calculate first in terms of radians per second. So it is going to be omega c plus 10 into 4000 pi into cos of, I am just differentiating it, so it will be cos of 4000 pi t plus 5 into 2000 pi into cos of 2000 pi t. So what is the frequency deviation? It is the frequency of carrier wave. So the carrier frequency is getting deviated by this value, by this amount of frequency. That is, it is your frequency deviation. It is your frequency deviation. And del f is what? Or del omega is what? Maximum frequency deviation. Therefore, if you see maximum frequency deviation, that is del omega. First, I am calculating in terms of radians per second. So for maximum value, you just have to take t is equals to 0, because cos will be 0 at 0 value of argument. So cos 0 will be 1 here, cos 0 will be 1. So maximum deviation is equals to 10 into 4000 pi, that is 40,000 pi, plus here it will be 2000 pi into 5, that is 10,000 pi. At t is equals to 0, for maximum frequency deviation, you have taken t is equals to 0, because cos signal will be maximum at 0. So now, if you take total value is equals to what? 50,000 pi radians per second. So if it is del omega, then to find del f, or we can say that del f is equals to del omega upon 2 pi. So if you will be dividing this value by 2 pi, then you are going to get 25,000 hertz. So what we have obtained is 50,000 pi divided by 2 pi, that is equals to 25,000 hertz. So now we are having del f, we are having fm. So if we are having del f and fm, then we can calculate beta. Therefore, what we are having is del f we have already calculated to be 25,000 hertz. Fm we have already seen from the given question, that is fn is 2000 hertz. Therefore, beta will be del f upon fm, that is equals to 25 by 2. And if you have calculated the value of beta, therefore bandwidth is either twice times beta plus 1 into del f fm in hertz if you are calculating. So it will be, or you can directly take the equation for bandwidth as this also, that is twice of del f upon fm. So you can calculate from here also without calculating the value of beta. But if we have calculated beta, then we can go with this. So it will be 2 into beta plus 1 will be what? Beta plus 1 will be 25 plus 4, that will be 27. Beta plus 1 will be 27 by 2. And fm is equals to 2000 hertz. So if it is 2000 hertz, then it is 2, this 2 and 2 will get cancelled, and 27 into 2 will be 54,000. So bandwidth required for this given signal is, bandwidth is equals to 54,000 hertz, or we can take it as 54 kilohertz. Accordingly, you can select the correct option. And if you see the options, so if 54 is present, yes, it is present in option C. So this option C is correct for the given question. Are you able to get this correct complete solution? Gate 13.5 is not correct. Ravi, 12.5 is absolutely correct for the value of beta, and therefore overall bandwidth is 54 kilohertz, which is absolutely correct. Very good. Moving to the next question. In an FM wave is represented by the equation. See, if you just know the value of expression of FM wave, then such kind of questions can be solved just by comparing it by the standard equation, because we just have to calculate what is the carrier frequency. So what you know from the standard equation of FM wave is, standard equation we have written that x fm of t, it is equals to AC cos of omega ct plus beta sine of omega mt. Just compare it with the given value. So it is AC, sine or cos doesn't matter, it is your omega c, it is your beta, and it is your omega mt. So if you see, what we have to calculate is carrier frequency. Therefore omega c, carrier frequency in radians per second, is 9 into 10 to the power 8, or you can write 9 into 10 to the power 2 into 10 to the power 6. If you have to calculate in 10 to the power 6 megahertz, so it is in radians per second. But if all the options are in hertz, therefore it means you have to calculate carrier frequency in hertz. Therefore it will be 9 into 10 to the power 2 is 900. You just have to divide it by 2 pi into 10 to the power 6 can be written as megahertz. So 900 upon 6.28 you just have to calculate, and if you calculate the value of 900 upon 6.28, then it is going to be 143.31. This is 143.31 megahertz, and accordingly option C is correct for the given question. Next, consider the following statements about FM. Modulation index determines the number of significant sideband components. We have just discussed it in the theory section. That is absolutely correct. Beta decides, because on beta the Bessel functions J0 of beta or J1 of beta or J2 of beta will be deciding, depending. Therefore statement 1 is absolutely correct. Next, if you see, the second statement says that theoretical bandwidth is infinite, is absolutely correct. Carrier suppression is not possible, it is absolutely wrong. What we have seen is, it is possible for the carrier wave to get completely vanished for some values of beta, that is 2.4, 5.5, 8.6, 11.8. Therefore carrier may get suppressed completely. Therefore this option is not correct. Sidebands are not symmetric about the carrier, it is also not correct, because if you see here, I have plotted the waveform spectrum of FM wave for you. it is carrier frequency omega c, and sidebands are symmetric about this carrier frequency omega c minus omega m, omega c plus omega c minus 2 omega m, omega c plus 2 omega m. Means sidebands are symmetric about this carrier frequency. Therefore, this option, this fourth statement is again not correct. So if you see here, it is not correct. So correct statements are only 1 and 2, and accordingly option B is correct. So if you see, we have discussed some theories of FM and PM, and you must be able to solve all these questions instantaneously. Next, the de-emphasis filter in an AM receiver comes before demodulator, after demodulator, and before sideband filter. Yes, it is the correct option, and for this I have taken the block diagram of this FM receiver. So if you see here, de-emphasis circuit it may not be very clear to you, but it comes after discriminator, that is, it is after the demodulator but before the filter. So this option, before baseband filter and after demodulator, is correct for this de-emphasis filter circuit. And de-emphasis is used at the receiver end of FM. So you just have to keep in mind that pre-emphasis is used at transmitter end. And why it is used? To boost higher frequencies, because noise predominates at the higher frequency in FM. Okay, moving to the next question. An indirect way of generating FM is, I have already told you in the theory section, that Armstrong modulator is the indirect method of frequency modulation generation. Next question, मैच लिस्ट 1 with 2. तो जैसे मैंने आपको पहले भी बताया कि ESE के जो क्वेश्चंस होते हैं, अगर आपको मैच करना है 4, तो जरूरी नहीं कि आप चारों के लिए ही आप परेशान हो, कि आप अगर इसमें से 2 आते हैं, आपको 2 नहीं आते, तो आप देखेंगे ESE के जो ऑप्शंस फ्रेम किए जाते हैं वो ऐसे किए जाते हैं कि अगर आपको 2 भी ऑप्शंस मैच करना आ रहा है तो आप उससे ऑप्शंस को मैच करेंगे, बिल्कुल आपका ऑप्शन आपको मिल जाएगा कि कौन सा ऑप्शन करेक्ट होगा. जबकि गेट में क्वेश्चंस को ज़्यादा कॉम्प्लिकेटेड बनाकर दिया जाता है. जो 2 ईजी ऑप्शंस होते हैं वो सब में आपको सेम दिखेंगे, या ज़्यादातर में आपको 2-3 में सेम दिखेंगे, वहाँ से आप नहीं चुन सकते. ESE में टाइम मेन कंसर्न है, इसलिए यहाँ पर आपको इतनी लिवरेज दी जाती है. तो देखिए, जैसे आपको क्या पता है, FM रिसीवर है और यहाँ पर डी एम्फेसिस फिल्टर. तो एक तो आपको ये पता है, अभी अभी हमने देखा कि FM रिसीवर में ही डी एम्फेसिस फिल्टर यूज़ किया जाता है. और आपको क्या पता है, सुपर हेट्रोडाइन रिसीवर ये किसके लिए यूज़ होता है. ये आपको पता है कि सुपर हेट्रोडाइन में हमने इंटरमीडिएट फ्रीक्वेंसी की बात की थी, मतलब वहाँ पर क्या होते हैं, मिक्सर्स होते हैं. तो ये 2 भी अगर आपको आते हैं, ठीक है, थोड़ी देर के लिए मान लीजिए, या आप ये भी जानते हैं कि एनवेलप डिटेक्टर मतलब इसमें डायोड्स लगे होते हैं. मान लीजिए आपको ये नहीं पता, ठीक है, मान लीजिए आपको सुपर हेट्रोडाइन रिसीवर में मिक्सर होता है, ये भी नहीं पता. एनवेलप डिटेक्टर को डायोड डिटेक्टर भी कहते हैं, इतना पता होगा तो हो सकता है कितना आपको बस पता हो. सिर्फ इन दोनों को लेकर देखिए कि सी का ऑप्शन 2 होना चाहिए और डी का ऑप्शन 3 होना चाहिए. सी का 2 और डी का 3 एक ही ऑप्शन में आपको दिख रहा है, तो बस ये ऑप्शन सेलेक्ट आप कर सकते हैं, ठीक है. अदरवाइज अगर आप चारों को भी देखेंगे तो बिल्कुल पता तो होना चाहिए आपको, लेकिन ESE में पता नहीं, इसका मतलब ये नहीं कि क्वेश्चन बिल्कुल ही नहीं बनेगा. ज़्यादातर चांसेस ये हैं कि आपसे क्वेश्चन सॉल्व हो जाएगा. अच्छा, इसके बाद अगर बाकी 2 को देखें तो जैसे हमने बात की, मिक्सर कहाँ होता है, सुपर हेट्रोडाइन रिसीवर में इंटरमीडिएट फ्रीक्वेंसी जनरेट करने के लिए वहाँ पर हम मिक्सर लेते. अब इसके बाद एक बचा फेज लॉग लूप. तो इसके फेज लॉग लूप में हमेशा ध्यान में रखिएगा, फेज लॉग लूप से रिलेटेड जो ESE में टर्म्स आएंगे, तो फेज लॉग लूप में 4 चीज़ें होती. फ्रीक्वेंसी, एक तो फेज डिटेक्टर होता है, एक होता है ये वोल्टेज कंट्रोल्ड ऑसिलेटर, फिर एक होता है हमारा एम्पलीफायर, DC एम्पलीफायर. तो यहाँ पर मैंने आपके लिए डायग्राम भी रख दिया, तो ये इसको देख लीजिए. फेज डिटेक्टर, लो पास फिल्टर, DC एम्पलीफायर एंड VCO, दैट इज वोल्टेज कंट्रोल्ड ऑसिलेटर. इनके लिए एक लाइन भी मैंने लिख दी है, उसको आप जब मैं ये शेयर करूँगा आपको PDF, तो ये सब भी आप पढ़ लिया कीजिएगा. अदरवाइज ये बहुत इंपॉर्टेंट है. फेज लॉग लूप के जो एलिमेंट्स हैं, फेज डिटेक्टर क्या करता है, यहाँ पर सब कुछ लिखा भी हुआ है, वैसे भी आप जानते हैं इतनी थियरी. तो उसके अकॉर्डिंग फेज लॉग लूप VCO phase lock loop, and accordingly if you see, for A there must be 4, for B there must be 1, C FM receiver you will select 2, and for D envelope detector you will be selecting 3. Therefore option A is correct. Moving to the next question. In phase modulation, phase deviation is proportional to, see, in this question it is not phase, it is frequency. the actual question, it must be in phase modulation, frequency deviation is proportional to. It is ESE 2011 question. If you observe from the expression of phase modulated wave that we have already discussed, that is, we have written expression for phase modulation, xpm of t. We have written it as AC cos of omega ct plus kp into mt. And at the place of mt, if we write mt is equals to am sine or cos am cos omega mt. If it is your baseband signal or modulating signal, so kp into am cos omega mt. So if you see phase deviation, then it is the phase deviation. For phase deviation, if you see, then in phase modulation, phase deviation is directly proportional to, it is the phase deviation. If we are concerning the phase deviation, then you can say it is phase deviation. This complete term is deviation of phase from actual phase of carrier, and actual phase of carrier was omega ct. So this part is representing phase deviation. Phase deviation. So what we can see here from here is phase deviation is directly proportional to the message signal m of t as well. Phase deviation is directly proportional to message signal m of t, or linearly you can say that phase will be linearly varying with the message signal. But if you see, if you have to find the answer for frequency deviation, then if it is instantaneous phase angle theta I of t, that is omega ct plus kp am cos omega mt. So if you have to find the frequency deviation, then to find frequency, instantaneous frequency first, you will be differentiating this phase, and that will be omega c plus differentiation of cos omega mt will give you omega m times sine omega mt with a minus sign. So it will be kp am omega m into sine omega mt, right? So if you see again here, if you have to answer it for frequency modulation, for frequency deviation, then frequency is deviating from this actual frequency of carrier wave by this amount. It is frequency deviation. Maximum frequency deviation is what? Maximum frequency deviation, that is del omega. Maximum value of the signal sine is 1. Therefore, maximum frequency deviation magnitude we are talking about is kp am omega. So maximum frequency deviation, if you have to check, then maximum frequency deviation, therefore del omega is proportional to omega. That is, maximum frequency deviation is proportional to frequency. And if we have to find for phase deviation, then phase deviation is directly proportional to the message signal itself. It completely, the phase is depending on this message signal m of t. You can say that phase is linearly varying with respect to your message signal. So for phase deviation, you will be selecting phase deviation is proportional to message signal. It is your phase deviation, and phase deviation you can write kp is a constant. Therefore, phase deviation del theta is equals to kp into mt, or you can write that is del theta is proportional to m of t. If you have to answer for phase deviation, then it is the answer, that is, it is absolutely proportional to message signal. And if you have to answer for frequency deviation, then you will be writing that frequency deviation is proportional to the message signal frequency omega. So accordingly, option C is correct for this question. Next, the main advantage of pre-emphasis circuit in FM transmitter. We have already discussed in the previous session as well that pre-emphasis is used to boost higher frequencies at the transmitter end of FM modulator. And accordingly, you can select the option to increase the carrier power, no. To improve signal to noise ratio at low audio frequencies, no. To improve signal to noise ratio is correct, but for higher frequencies. To increase the bandwidth of sideband, no. To improve the signal to noise ratio at high audio frequencies, yes, it is the correct option. So option D is correct for question number 19. Is everyone able to get all the options, all the answers? Yes. Gate, you are absolutely correct. Next. So Gate, you have answered message signal frequencies is correct for previous question if frequency deviation is being asked. But if it is asked about the phase deviation, then total message signal will be the answer. Okay. Next, in a frequency modulation system, maximum frequency deviation allowed is 1000. What we have given is del f you are having as 1000. And modulating frequency is 1 kilohertz. Again, it must be in hertz or in kilohertz. So if it is missing, normally the maximum frequency deviation you can take is 75 kilohertz. It is a general value of del f in case of frequency modulation. So it must be in hertz, kilohertz. So I am taking it at 1000 kilohertz. So del f is 1000 kilohertz and modulating frequency is 1 kilohertz. Okay, if it is not given here, let's say it is in hertz, because if we take the options, so let's say it is in hertz, it is given in hertz, so it must be mentioned in the question, but it is missed by the typewriter, so we have to consider any one value. If we consider del f to be 1000 hertz and fm is given to be 1 kilohertz, that is again equals to 1000 hertz, then in that case beta is equals to del f upon fm, and that is going to be 1000 upon 1000, that is equals to 1. So if I consider del f 1000 hertz only, then beta is equals to 1. If I'll be considering 1000 kilohertz, because 1000 kilohertz is very large value for frequency deviation, so 1000 kilohertz is not practical, so I am taking 1000 hertz. Therefore accordingly the value of beta is 1. Next, which one of the following statement is not correct? FM has infinite number of sidebands. It is correct. We have already seen in case of wideband FM. Modulation index for FM is always greater than 1. No. It is the case in case of wideband FM. But in narrowband FM, beta can have very small value as well. So in narrowband FM, beta can be very much lesser than 1 as well. So option, it is not correct. So if we have to check which one is not correct, then we have already got our option, that is option B. If you see the next two options, as modulation depth increases, it means as you are going to increase beta, the bandwidth increases. Yes, bandwidth is function of beta, and if you are going to increase beta, then bandwidth will get increased, means this option is correct. As modulation depth increases, the sideband power increases. Yes, we have already seen that beta determines the significant sideband powers, how many sidebands will you present at the receiver end. So the correct option, if we have to select the wrong statement, then option B is correct. Next, in a frequency division multiplexed system, crosstalk occurs due to. This crosstalk, it is mainly, it is due to the because of leakage between adjacent channels. Means you can say interference between adjacent channels, and main reasons for this, the very first reason is poor filtering, absence of guard band, very close channel locations. So it is because of leakage in coupling. So crosstalk means if signal from one channel interfere with the signal from other channel, adjacent channel. So main reason of crosstalk is poor filtering. If you are not able to properly, you can say that is one more reason can be poor selectivity. So if you see the options, imperfect time synchronization between transmitter and receiver, no. Imperfect filtering at the receiver front end, it is absolutely correct. Whenever if you are having filtering option in case of crosstalk, then you can select that option. Option C is imperfect carrier recovery at the receiver is not correct. Channel noise is not correct. So imperfect filtering at the receiver end is correct for this crosstalk. Next, in FM modulation, when the modulation index increases, the transmitted power. See, what term it is used here is transmitted power. I have already told you that transmitted power is always constant, but received power will depend on beta or on the bandwidth. As you are going to increase the bandwidth, then the received power will be increasing, but transmitted power is always constant, that is equals to carrier power. So if you see here, unchanged is the correct option. If received power will be there, so with increased modulation index, received power will get increased. So option C is correct for this question. Next, an FM signal is represented by this. So you just have compare it with AC cos or sine omega CT plus beta sine omega MT. And accordingly, the carrier frequency, it is omega C. It is what? It is omega C. So FC will be what? This omega C, that is 6 into 10 to the power 2 into 10 to the power 6 divided by 2 pi. Because it is your omega C. So to find carrier frequency in hertz, you have to divide it by 2 pi. So it is your carrier frequency and deviation. So to find deviation, what you can see from here is you are having omega m as 2050 hertz, 1250 hertz. So FM will be 1250 divided by 2 pi. Omega m is 1250 radians per second. So FM will be 1250 divided by 2 pi hertz. It is FM and you are having beta. Beta value, you can say it is beta sine omega mt. So beta is equals to 5. Therefore, del F is what? Del F is beta is del F upon FM. Beta is what? It is del F upon FM. So del F is beta times FM. Beta into FM. And accordingly, the value will be 5 into this 1250 upon 6.28. The value you must be calculating. $199.044, and that is going to be into 5 is 995.22. So it is the value of del F, and from here if you calculate FC, then it is 600 upon 6.28. So 600 divided by 6.28 will give you 95.54. That is 95.54 hertz. And accordingly, you can select 95.5 and 995. That is option B is correct for this given question. Have you got the answer? Yes, 95.49 is correct. Very good. Gate and Ravi, both of you are correct. Moving to the next question. The 4 basic elements in PLL we have already seen. In PLL, phase, detector, then we are having DC amplifier, then we are having VCO, and here low pass filter in between these two. So before this, we are having a low pass filter. So it is the diagram of your phase log loop, and accordingly phase detector is correct option, so option C is correct. Next, in a frequency modulated system, when the audio frequency is 500 Hz and audio frequency voltage is 2.4 volt, what we are given in this question is, what we have given is audio frequency means FM is equals to 500 Hz and audio frequency voltage, that is AM, is 2.4 volt. The frequency deviation is, in this case, frequency deviation del F is 4.8 kilohertz. What we have already seen is, we have written Kf times AM is equals to omega m. But when Kf times AM is equals to del omega, if this Kf is in radians per second per volt, then it will give you Kf into AM will give you del omega, that is in radians per second. Because if you see here, radian per second per volt into volt, value of AM is in volts, so volt get cancelled and you will be having radians per second. But if you take this Kf into AM only, but if the unit of Km you are taking in Hertz per volt, then it will be del F. Then it will give you del F in Hertz. So in this case, you are having FM, AM and del F. So del F it is in 4.8 kilohertz in Hertz. Therefore, you can write from this given condition, that is Kf into AM is equals to what? Del F. So AM you are having here, so Kf into AM is 2.4 is equals to del F, that is 4.8 kilohertz. Therefore Kf, this is frequency sensitivity which is a constant for an FM modulator. It is not going to be changed. You will now going to change the carrier, the modulating signal frequency, but this frequency sensitivity of the modulator will remain unchanged. So from the given condition, we have calculated the value of Kf. So Kf is equals to, if it is to 4.8 kilohertz, 4.8 kilohertz, so it is going to be 2000. That is 4.8 into 10 to the power 3 upon 2.4. Therefore, it is going to be what? 2000. So it is fixed. Kf from the first condition, from first given condition, you have calculated the value of Kf. Now, for the next condition, you have to find out the new value of deviation. Now, for the next condition, case 2, you have to find the value of deviation, whereas the audio frequency voltage, that is AM, is now 7.2 volts. Kf will remain same. Kf is equals to 2000 only. It is constant for FM modulator. For every modulator, frequency sensitivity is kept constant. So Kf is 2000 only. Therefore, new deviation del F is equals to, again we are going to use Kf times AM only. So it is going to be 2000 into 7.2. So it is going to be what? 14.4. That is 14.4 kilohertz. 2 into 7.2 is 14.4 and 1000 is taken as kilohertz. So accordingly, option D is correct. Is it clear? Yes, option D is correct. 14,400 Hertz is absolutely correct. Very good, Ravi. Next, a PLL detector uses a VCO with Kf is equals to 1000 kilohertz per Newton. Not it must be volts. If it receives an FM signal with a deviation of 75 kilohertz and sine wave modulation, what is RMS output voltage from the detector? Now, if you see here again, del F is equals to what? Del F is Kf into AM. So you are having Kf is given as 1000 kilohertz per volt. and del F is given. Del F is 75 kilohertz, which is the standard value of frequency deviation in case of FM modulator. So if you put the values, then you can find the maximum, that is amplitude of sinusoidal wave. So AM is equals to del F upon KF, that is equals to 75K divided by 1000K. That is going to be what? 3 upon 40. If we divide from 25, so 3 upon 40 is the value of AM. So therefore, if we have to calculate the RMS output voltage, their RMS output voltage will be taking AM by root 2. So it will be 3 upon 40 root 2, and you have to find out the value. So what is the value? Have you calculated it? 3 by 40 is 0.075, and if you divide it further by 1.414, that is root 2, then it is going to be 0.053. It is going to be 0.053 volts, and accordingly option D is correct. I hope all of you have obtained the result. That is option D is correct. Yes. Next, again we have to match the first column with the second. So just use how many matching you can perform without any lack of concept, that is super heterodyne receiver. You know that, so in super heterodyne receiver there comes the concept of image frequency. So if we have to make match these first column with the disadvantages, so in super heterodyne receiver there is a disadvantage of image signal. And in case of FM, what you know is, in case of FM, okay, if I have not discussed in case of FM the threshold effect first, so because it will be, FM will be correctly matched with the threshold effect, but still if you say, if you are not able to understand what is threshold effect and how it is related to FM, for the time being you just have to put it on hold. Next, if you see PCM, then you must be aware that PCM has two advantages. PCM, you have a disadvantage of having quantization noise, because in PCM when you will be converting, you will be generating the quantized or staircase waveform approximation, then there must be some quantization noise. So in case of PCM, if you are able to match it with quantization noise, then you can select the options as well. Or in most common cases, every student must be knowing that delta modulation has two disadvantages, that are granular noise effect and slope overload effect. So you must be matching it with granular noise, and then the remaining FM is going to be what? Threshold effect. So either if you are only able to solve any match any two columns, then for, let's say for C there should be 4, so there are two possible options, and for D there should be option 2. So in this case you are having some problem, but still if you are able to match all the 4 options, then for C there should be 4, for D there should be 2, for A the option should be for 3, for A there should be 3, it means option B is correct. Now what the threshold effect is? Threshold effect in FM comes when signal to noise ratio at the transmitting end falls below a particular threshold value. Then due to this, the signal to noise ratio at the receiver end rapidly falls from its value. So threshold effect is if SNR at input falls below a threshold value, then SNR at output, or you can say at receiver falls rapidly. It is known as the threshold effect in frequency modulation. So you are already got the option for this question, that is option B is correct. Moving to the next question. when an audio receiver is tuned to 555 kilohertz, its local oscillator provides the mixer with an input at 1010 kilohertz. See, it is the question from super heterodyne receiver. So in case of super heterodyne receiver, what you must be understanding is, first is image frequency, FSI. Image signal frequency is equals to Fi is equals to Fs plus 2I, 2 times intermediate frequency. And this Fs is nothing but the RF frequency for which your receiver is tuned, the RF frequency which is looking by the receiver. So this Fs, it is also equals to local oscillator frequency, that is FLO plus IF. This signal frequency is equals to FLO plus IF. So it is equals to see, we are having this local oscillator frequency of local oscillator. What we have already written is, it is equals to signal frequency plus intermediate frequency, and image frequency is equals to local oscillator frequency plus image frequency. Local oscillator frequency is kept intermediate frequency times greater than your signal frequency at which your receiver is tuned. So FLO is equals to Fs plus IF, and image frequency is equals to, image frequency is intermediate frequency more than the local oscillator frequency. At the place of local oscillator, if you put this value Fs plus IF, then it is going to be what? It is going to be Fs plus 2IF. So it is give you the value of image frequency. So what you are having in the problem is, in the given problem we are having, receiver is tuned at 455 kilohertz, means Fs, either you say the frequency of RF carrier which is looking by the receiver, it is Fs is equals to 555 kilohertz, and local oscillator frequency is given as FLO, local oscillator frequency is given as 1010 kilohertz. Therefore, what you can calculate from these two values, therefore you can calculate the value of intermediate frequency. Intermediate frequency is, from here also you can calculate, intermediate frequency is FLO minus Fs. It is local oscillator frequency minus RF carrier frequency, that is equals to 1010 minus 555, that is equals to 455 kilohertz, which is the standard value for super heterodyne receiver. It is the standard value of intermediate frequency for super heterodyne receiver in India. So IF is 455 kilohertz, and as soon as you have obtained the value of intermediate frequency, so if you have to calculate, see here what is been asked, what is the frequency of the other station, that is, at the output another signal is also received. So which signal will pass the mixer? Which is the image signal frequency. So that frequency will also be passed from the mixer. Therefore, at the other station, the frequency is asked, that is nothing but the image frequency. Therefore, image signal frequency is equals to Fs plus 2IF, that is equals to Fs is being 555 and plus 2 times 455 will give you 910. Is it correct? 910, yes. So it is going to be 9 plus 5, 15, 14, 1465 hertz, 1465 kilohertz. So this will be the frequency of image signal, and it will be available at the other station, and accordingly option D is correct. Moving to the next question. Which one of the following statement is correct? The threshold effect in demodulators is, I have already discussed it. Threshold effect is when input or the transmitting at the transmitting end, when the SNR falls below a threshold value, then it causes the rapid fall in the output SNR or SNR at the receiver end at the demodulator. So you just have to check for that option. The rapid fall in the output SNR when input SNR falls below particular value, that is the threshold value. So this option C is correct about the threshold effect in FM demodulators. Next, in a radio receiver, automatic gain control works by. Automatic gain control is what? See, in audio section, RF and IF amplifier gains are varied by a single operation, that is, are simultaneously varied. If received signal strength is poor, high gain, it requires high gain, and if strength is fairly enough, fair, then low gain. It is the for both RF and IF amplifiers. RF and IF amplifiers. It is the main purpose of automatic gain control. If you are using any audio microphone, so what you would like is, if the coming sound is large or fairly high volume, then it doesn't require any extra amplification. But if the incoming signal is weak, then for proper hearing, you must be wanting it to be amplified by a larger amount. So it is the process of automatic gain control, that if the incoming signal is having weak strength, then automatic gain control circuit gives the gain to RF and IF amplifier more gain, and if the strength is fairly enough, then it provides RF and IF amplifiers lesser gain, so that to maintain constant SNR. Why? To maintain constant SNR, therefore you must be able to hear all the sounds at a proper level. Therefore the option for this question is adjusting the gain of RF and IF amplifiers simultaneously. We use automatic gain control is correct option. Moving to the next question. For a citizens band receiver using high side injection with an RF carrier of 27 MHz and IF center frequency of 455 Hz, what is image frequency? Actually, you just have to calculate the value of image frequency. And for image frequency, what we have already seen is image frequency is equals to Fs plus twice of IF. So if it is tuned for RF carrier of 27 MHz, then you are going to get 27 plus twice of, if 27 is in megahertz and if it is in kilohertz, so to convert it in megahertz as well, so you will be taking 2 into 0.455. It will be, if it is 455 kilohertz, then you can write it like 0.455 megahertz, and accordingly it is in megahertz, because all the options you are having in megahertz, so I have converted both in megahertz. So it is going to be 27 plus, it is 0.91. Yes, that is equals to 27.91 megahertz, and accordingly option B is correct for this given question. Please wait. Okay, is it clear? Option B is correct. Yes, Ravi, your option is absolutely correct. Moving to the next one. In the receiver parameter, fidelity is a measure of. Fidelity is a measure of how closely, see, when we accept at the receiver end, how closely we reproduce the baseband or message signal, how closely the message is reproduced at receiver. So it is a measure of fidelity is a measure of how closely the message is reproduced as the receiver end. So you just have to select the options. The ability of a communication system to produce at the output of the receiver an exact replica of original source information is the correct option. It is the correct option. That what I have written here. That is how much closer is the, or you can say how precisely the output the message signal or information is reproduced as the receiver end. So option C is correct for this question, that is fidelity is what. Next, which one of the following statement is correct regarding tuned radio frequency receiver? See, in case of tuned radio frequency receiver, that is TRF receiver has the main problem of selectivity. That is low sensitivity, no. Selectivity is the correct option. That is, if you see FM range, you have said that for AM receiver 540 kilohertz to 1650 kilohertz, in this range TRF receiver will be used, right? Now what you know is bandwidth is equals to what? Bandwidth is equals to, you know that bandwidth is FR upon Q, resonant frequency upon quality factor, right? So bandwidth, or you can say that quality factor is equals to resonant frequency upon bandwidth. So in case of AM, for amplitude modulation, bandwidth is equals to what? Twice of FM, or twice omega m, or twice of FM in case of, and maximum value of frequency is 5 kilohertz. Normally FM is nearly equals to 5 kilohertz. That is, the voice signal that will be transmitting through AM is nearly about 5 kilohertz maximum range. So if FM is 5 kilohertz, bandwidth is twice of FM, that is 10 kilohertz. So if you are going to check for this lower frequency range signals, so Q is equals to FR upon bandwidth, that will be 540 upon bandwidth is 10, then it is equals to what? 54, which is practical value, practically possible. This Q, if you see the quality factor of filters, it lies in the range Q value less than 100. Practical range for quality factor is less than 100. So if you have to transmit with this carrier, that is 540 kilohertz, then you will be requiring the value of quality factor that is equals to 54, which is practically possible, right? But if you have to transmit with this signal, then for this, if you see quality factor, then it will be what? FR upon bandwidth at high frequency end. Then it is equals to what? FR is 1650 kilohertz and divided by bandwidth is 10 kilohertz. Then it will be what? 165. 165, which is not practically possible. Not practically possible. It is not practically possible. So what you will have to do is, if you want to send messages with this carrier 1650 kilohertz, then you must be increasing your bandwidth to keep the quality factor within the practical range. Therefore, bandwidth need to be increased. Therefore, TRF, that is tuned frequency receivers, is having mainly the problem of variable bandwidth. For frequencies up to, let's say, 540 kilohertz to 1000 kilohertz, you will be able to use the bandwidth of 10 kilohertz, which is absolutely correct for AM. Bandwidth is twice of FM, that is equals to 10. But if you are going forward with increased frequency, that is 1650 hertz, from 1000 to 1650, the quality factor is getting impractical, and to make the quality factor in the practical range, you need to increase your bandwidth. Therefore, TRF in TRF receivers, it suffers from the problem of variable bandwidth. Therefore, if you see here, the bandwidth is inconsistent and varies with the center frequency when tuned over a wide range of input frequencies. Therefore, this option is absolutely correct. If you see other options, it is stable due to the large number of RF amplifier all tuned to the same center frequency. This statement is correct, that is all tuned to the same center frequency. But due to this, there may be possibility of positive feedback from the stray elements. Therefore, it makes the system unstable. It is not making the system stable. It is said to be ganged. All the RF stages are tuned simultaneously. Therefore, they are said to be ganged in between. So, if you are tuning all the stages simultaneously, then it can make the system unstable. So, this statement is wrong. Next, the gain is uniform over a wide frequency range. It is again not correct. And it has a very low sensitivity. It is also not correct. So the correct option is option A. So in TRF, it suffers from variable bandwidth if you are going to use it for higher frequencies. Next, which one of the following is a figure of merit? Figure of merit is used to indicate how much the signal to noise ratio deteriorates as a signal passes through a circuit or series of circuits. So see here in the options, what you have to check is which one is the figure of merit. Impulse noise is a type of noise. Correlated noise again is a type of noise. It is not figure of merit. Figure of merit, if you see noise figure and noise temperature, these two are figure of merits. It may be taken as figure of merits, but it is lesser. You can say it has lesser impact. But the main figure of merit is noise figure, which is given as SNR at input to the SNR at output. It is the ratio of signal to noise ratio at input to output, and it is basically the figure of merit to indicate how much the signal to noise ratio deteriorates from input to output. So accordingly, option B is correct. Next, if you see, time division multiplexing is used when the data to be transmitted is. See, what you do in time division multiplexing, you have a channel, you have this channel bandwidth, you allocate this complete bandwidth for different signals but for different slots of time. So if the data is rapidly fluctuating, then for the time being, let's say for 1 microsecond, let's say you are giving this complete bandwidth to 1 microsecond for every individual user. So if the data is changing rapidly, so in 1 microsecond, because after, let's say you are giving it at 1 second, then at next time the user will have access for this channel or this complete information after 1 microsecond. So if the data is changing rapidly, then he will be missing some information. Therefore, TDM in time division multiplexing, it is used for users having slow changing data. Therefore, we can, if we are dividing the users in time slots, then between the time slots, the data is not changed rapidly, so that he can understand by joining the two time slots that he had. Therefore, slow changing is correct. Again, if you see, slow changing and has a small bandwidth, actually small bandwidth is not correct in that sense, because in time division multiplexing, every user has control of the entire bandwidth for his allocated time slot. But if you see here, it can be taken as small bandwidth, because for individual users, if individual users are having data which is slowly changing and has small bandwidth, then we can still use time division multiplexing. So if we have to select from these given options, then most appropriate option we can select is slow changing data and a small bandwidth. It will be efficient for time division multiplexing, and accordingly option C is correct. So in time division multiplexing, we are allocating the complete channel bandwidth to each user, but for a selected time slot. Next, which one of the following PCM scheme is depicted in the figure below? See, if you have read the concepts of delta modulation and adaptive delta modulation, then you must be able to answer this question, because what we are going to perform here is, by this block diagram, we are having a comparator, and after comparison of the signal, we are just generating either positive or negative steps. Therefore, it is the diagram of delta modulation, not adaptive delta modulation. In adaptive delta modulation, the step size will be variable, and for that we need additional circuitry. Therefore, this diagram depicts the process of delta modulation. Next, assertion. Slope overload is a problem in DPCM. It is absolutely wrong. Slope overload is a problem in delta modulation, non-differential pulse code modulation, because in differential pulse code modulation, you are not going to encode the entire information. You are just going to encode the difference between the sample with its previous sample. So in case of DPCM, it is not having the problem of slope overload. So if A is wrong, then you are having only one option, that is option D. If you see the second option, DPCM, that is reason, DPCM makes use of adjacent sample correction, is correct. It is correct, but it is not the correct reasoning of A, therefore option D is correct. Next, the maximum number of quantized amplitude levels in a 3-digit ternary PCM system. So you know that number of quantization levels, L is equals to 2 to the power n. And if you are having number of digits equals to 3, that is, if you are encoding every sample in 3 bits, then number of levels will be, that is equals to 2 to the power 3, that is equals to 8. Number of quantized amplitude levels will be what? 8. Or you can also write, that is, n is equals to log base 2n. If you have to calculate the value of number of bits, n is what? Number of bits in which each sample is encoded. Okay, moving to the next question. One disadvantage of adaptive delta modulation over linear delta modulation is that it requires more bandwidth, is not correct. Both delta modulation and adaptive delta modulation requires same bandwidth. Is more vulnerable to channel errors? See, in this question, if you see here, if you read other options, requires a large number of comparators in the encoder, is wrong. Both delta modulator and adaptive delta modulators both uses only one comparator. So this option is wrong. It is not suitable for signals with periodic components. It is more suitable. Adaptive delta modulation is more suitable for periodic components, as it can remove the granular noise effect. Therefore, it is also wrong. So we are left only with one option, that is, it is more vulnerable to channel errors, and therefore I am going to select this option as the correct one. That is, adaptive delta modulation suffers more, it is more chances to have channel errors. Okay. Next, which one of the following multiple techniques involves signal composed of light beams? CDM is what? It is code division multiplexing. FDM is frequency division multiplexing, time division multiplexing, and WDM is what? Wavelength division multiplexing. So by the name itself, you can identify, that is, WDM is, it involves signal composed of light beams, because we are having wavelength word here, and it is used in FDM. So OFDM, optical fiber communication, we use WDM, that is wavelength division multiplexing. So it is the correct option. Next, which one of the following statement is correct? In PCM, the conditional probability of error is proportional to. See, in PCM, normally probability of error you will not be finding in textbooks, but in most of the cases, probability of error, it is taken as Q function of EB upon N0, where N0 is what? N0 in this case you are given as noise power, but N0 what I have written here is, it is not noise power, it is power spectral density of noise, white noise actually. So probability of error is given as Q of EB upon N0, and this Q function, Q is a decreasing function of argument. It is a decreasing function of argument. When you will be discussing ASK, PSK, BPSK, then you must be observing this kind of terms, probability of error in every cases. But in PCM, normally you talk lesser about this. But still, if you see conditional probability of error, then it is the basic formula for most of the cases. What we will be using is quality factor EB upon N0. So if you see Q function is a decreasing function of arguments, it means as this factor is overall, this value EB upon N0 increases, the overall probability of LL will get decreased. One more thing, if you see from here, if it is power spectral density of noise, so generally what comes in your mind when the probability of error will increase, when noise will increase or when noise will decrease? If noise will decrease, then definitely probability of error will decrease. Therefore, and noise, if noise will increase, then definitely the probability of error will also increase. So the if you have to select from these options, so square root of Emax or square root of N0 is not correct. So you can write that probability of error basically depends on the value of noise. As the noise power spectral density increases, so the noise power increases, and as the noise power increases, the probability of error increases. So you can select the option that is probability of error, conditional probability of error is proportional to noise power. It is proportional to noise power. As the noise power gets increased, the probability of error will increase. Why you cannot check the peak signal energy? Because as the energy of the signal increases, the probability of error will get decreased. So if it is given to be inversely proportional, then we can select that option. But as it is not given inversely proportional, therefore we are going to select noise power, and accordingly option A is correct. Next, analog data having highest harmonic at 30 kilohertz means we are having an analog signal which has maximum frequency component of 30 kilohertz generated by a sensor has been digitized using a 6-bit PCM. So if you have to perform PCM or to digitize any analog data, you first have to sample it. So if FM is given to be, maximum frequency component of analog signal is given to be 30 kilohertz, then by the Nyquist sampling rate, Fs is what? Sampling frequency is twice of FM, that is equals to 60 kilohertz. It means 60,000 samples per second. We are having 60,000 samples per second to transmit, right? And each sample is digitized in 6 levels. So for 6 levels, how many bits will be there? If you are having number of quantization levels, we are not having bits, we are having quantization levels. So quantization levels, L, that is equals to 2 to the power n, that is equals to 6. Therefore n is what? N is equals to, if you take n equals to 1, then L should be 1. If you take n equals to 2, then L should be 2. If you take n equals to 3, then 2 to the power 3 will give you at least 6. Therefore n must be greater than or equals to 3. So we are taking n equals to 3. So n equals to 3, because 2 to the power n must be greater than or equals to L. 2 to the power n must be greater than or equals to L. So the value of n that will satisfy this condition is n equals to 3. So now you are having 60,000 samples per second, and you are going to encode each sample in 3 bits. Each sample is going to get encoded in 3 bits. Therefore, per second, how many bits you will be transmitting? That is what it is being asked in the question, what will be the rate of digital signal generated? Therefore, rate of digital signal is equals to 60,000 samples. 60,000 samples. Each sample is encoded into 3 bits. Therefore, total 1,80,000. It will be the number of bits per second. That is equals to 180 kbps. You can write 180 kbps. And accordingly, option D is correct. Accordingly, option D is correct for this question. Moving to the next question. To overcome slope overload problem, which type of the integrator is used in delta modulation? So delta modulation is having two problems, slope overload and granular noise. If the slope of the signal that is to be transmitted is very much higher, then the staircase approximation will not able to follow that signal. That is known as slope overload. And if the slope of the message signal is very less, or you can say if the message signal getting constant for any interval of time, then you will be having positive and negative impulses in case of delta modulation. So to avoid these two conditions, we use adaptive delta modulation, in which we can vary the shape of step size. Therefore, for this question, slope overload can be avoided using variable slope integrator is the correct option for this given question, which is used in adaptive delta modulation. Next, consider the following statements about analog data digital signal. Amplifiers used in repeaters produce additive noise. See, it is correct, but for analog signals. In case of digital system, in digital systems, repeaters, analog, we are having amplifier repeaters, we are talking about repeaters cancels noise, या आप कह सकते हैं clears noise and regenerates the message. So it is not correct. It is correct for analog repeaters, analog system, but in digital system, repeaters cancels or clears noise and regenerates the signal. So repeaters do not add noise to the system in case of digital repeaters. Next, FDM is used for digital signals, whereas TDM is used for analog signal. This is absolutely wrong. TDM is used for digital signals while FM is used for analog signals. So it is wrong. Next, with TDM, there is no intermodulation noise, whereas there is a concern for FDM. Definitely, as we have already discussed, that in time division multiplexing, we allocate the complete channel bandwidth to every user, but for a fixed time slot. So there is no chance of intermodulation effect, that is intermodulation noise, because any two sources are never going to be get interfered. Therefore, this option is absolutely correct. Next, conversion to digital signaling allows the use of efficient digital switching techniques. Which of the statements are true? Yes, it is absolutely true. If you will be converting analog signal to digital signal, then only you can use the digital switching. Therefore, this statement is also correct. So the correct statements are statements 3 and 4, and accordingly option B is correct. Option B is correct. If you are having any doubt, then definitely you can say. Increase strength, Ravi, for the previous question you have mentioned increase strength. See, I have already told you, if you increase the signal strength or energy, then probability of error will decrease. So you cannot say that probability of error is directly proportional to the increased strength. I hope you are getting my point, and definitely you will be answering now. Okay, next. Which one of the following signals can be applied to the delta modulator whose step size is this and sampling frequency is this? See, slope overload to avoid slope overload. See, what we will be generating an staircase approximation in case of delta modulation. So if you see here, the slope of message signal must not be exceeding the slope of the what staircase approximation you are generating. So if you see, to avoid slope overload, SFS, this is your step size. It is your step size which is fixed in what, in delta modulation, and it is the time duration for which you are going to take this step, either it is positive or negative. So this is the time duration, that is sampling interval TS. So what will be the slope of this? If you see here, so the slope is S upon TS, that is equals to S into Fs. So as long as this SFS is greater than or equals to slope of the message signal. So if the message signal, let's say you are taking message signal M of t, that is equals to AM sine omega mt. So what is the slope of this signal? Slope of this signal is d by dt of mt, that is equals to am into omega m into cos of omega mt. So the maximum slope d by dt of mt, maximum value will be what? The maximum value of this slope is equals to maximum value of cos is 1, therefore it will be am omega m, and omega m can be written as 2 pi fm, so it is 2 pi fm am. So if the slope of this staircase approximation, as long as SFS is greater than or equals to twice of fm am, twice of 2 pi fm am, 2 pi fm am, slope overload will not be affected, right? So what we have to check is, from the given options, which option is satisfying this condition. To check this, what you are having in this question is step size S is equals to 0.1, right? And sampling frequency is Fs is equals to 20 pi kilohertz, right? So left hand side you are having SFS is equals to, that is 0.1 into Fs is 20 pi into 10 to the power 3. This must be greater than or equals to 2 pi fm am. So now for each of the options you have to calculate. See here, if you cancel this 2 pi from here, then you are going to get that fm into am, fm into am, or you can write am into fm, whatever you write, am into fm. From here what you can see is am into fm is what? It must be less than or equals to what? 2 pi get cancelled, so it will be what? 10 into 0.1, that is 1, and 1 into 1000, that is equals to 1000. So am into fm must be less than or equals to 1000. Is it correct? So now if you check for each of the options, here in case of fm I am writing value of fm in each case. If it is omega m, then fm is divided by 2 pi, so it is fm is equals to 600. So fm is 600 and it is 2. So am into fm in this case, am into fm in this case is 600 into 2, that is 1200. Therefore this option is not correct. For this option, if you see here, fm is 2600 pi divided by 2, that is 1300 pi, 1300. Therefore in this case am into fm is what? 1300 into 1, that is 1300. In this case fm is equals to 500. Therefore am into fm is 500 into 3, that is 1500. Therefore this option is again not correct. If you see here, fm is equals to 200 and am is 4. Therefore in this case am into fm is 4 into 200, that is 800, which is less than 1000. That should be the condition. Therefore this option is correct. For this signal, slope overload will not be occurring if you are going to take step size 0.1 volt and sampling frequency of 20 pi kilohertz. So it is not correct, it is not correct, not correct. This option D is correct. Can you get the options? Can you get the solution? Yes, option D is correct. सर आज बहुत साल बाद आपको YouTube पे लाइव देख रहा हूँ. मैंने 2020 में आपसे सिग्नल्स पढ़ा था, तभी थैंक्स नहीं बोल पाया था. थैंक यू सो मच सीशियो, थैंक यू सो मच एंड ऑल द बेस्ट. आपके आगे जो भी आप करेंगे, इतने काइंड वर्ड्स आपने जो लिखे हैं मेरे लिए, थैंक यू सो मच फॉर दैट. और मैं बिल्कुल आपको बेस्ट विशेष देता हूँ कि पूरे जो भी फ्यूचर एंडेवर्स हों आपके, आप उन सभी में बहुत अच्छा परफॉर्म करें. थैंक यू सो मच. चलिए मूविंग टू द नेक्स्ट क्वेश्चन. For a 10-bit PCM system, the signal to quantization noise ratio is 62 bit. If the number of bits is increased by 2, then how would the signal to noise ratio changes? See, अगर हम signal to noise ratio देखते हैं in dB, तो SNR in dB ये हम कैसे लिखते हैं? It is given to be 6.02n plus 1.76. Nearly आप इसको 6n मान लेते हैं. मतलब for every 1 bit increment, for every 1 bit increment, that is if you are going to encode a particular message, let's say in 5 bits, then whatever signal to noise ratio you are getting, if now you are going to increase the number of bits in which you are encoding the signal to 1 bit, so the signal to noise ratio will increase by 6 into 1, that will be equals to 6 dB. So for every 1 bit increment in encoding, SNR gets improved by 6 dB. So if you are increasing by 2 bits, so the SNR will get increased by 6 into 2, that is equals to what? Increased by 12 dB, and it is the correct option. So you must be able to understand. And 3 by 2 ms square is the actual value when we are considering the absolute value of SNR. Next, we have to match the characteristics with the second, that is modulation. So capture effect is a characteristics of granular noise occurs in and guard band is required in. So you already know that guard band required in frequency division multiplexing. Granular noise effect occurs in delta modulation, and delta modulation is what? Granular noise effect. It occurs in what? It is in delta modulation, and delta modulation is also known as 1 bit PCM system. You must be aware of that. 1 bit PCM system. So delta modulation can be considered as a PCM system only, but it is a 1 bit PCM system. Therefore, you will be taking granular noise to PCM, right? Next, capture effect is a characteristics of what? Capture effect is a characteristic of FM. What FM receiver performs is, if the FM receiver, what is capture effect? I am just summarizing it. Capture effect. If receiver has 2 or more signals with equal, or you can say almost equal, equal frequencies, then it logs onto the one with high amplitude, or you can say with stronger one, and ignores the weaker one. अगर रिसीवर के पास दो ऑलमोस्ट सेम फ्रीक्वेंसी के सिग्नल्स पहुंचते हैं, तो उनमें से जो स्ट्रॉन्ग सिग्नल है रिसीवर उसको कैप्चर करता है, और जो वीकर सिग्नल है उसको इग्नोर करता है. इसको हम बोलते हैं कैप्चर इफेक्ट. So this capture effects arises in the FM system. So accordingly, for option A, there must be 3, 2 and 1. So 3, 2 and 1, accordingly this option A is correct. Moving to the next question. Next is, assertion is, equalizers are used in receivers to increase the SNR of the demodulator. As you read this statement, that equalizers are used in receivers is absolutely wrong, because equalizers are used in channels. Equalizers are used in channel, right? So if assertion is wrong, then you are left only with one statement on option, that is option D. A is false but R is true. So what is R? The equalizer is designed such that their transfer function is inversely related to that of the channel. Therefore, the non-linearity that the channel is producing, or you can say the errors that channel is producing, equalizer will counter that, because its transfer function is inversely related to the channel. So what you must be keeping in your mind, that equalizers are used in channel, not in receiver. Therefore option D is correct. Next, which one of the following pulse communication system is digital? Pulse amplitude modulation analog system. PCM system, definitely it is correct. That is, it is a digital system. Pulse position modulation analog system, pulse width modulation analog. So the correct one is option D. PCM is a digital, pulse communication system is digital. Next, most nice immune system is, again, it is analog, 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 SSB, analog, and PCM is digital. So digital systems are more immune to noise. Always digital systems are more immune to noise, because the process of quantization, because now you are transmitting the signal in the forms of 1 and 0, and there are several types of error correction and error detection techniques are available for digital communication system. Therefore PCM system, it has all the advantages of a digital system, and therefore it is more immune to noise. Next, for a 3000 Hz bandwidth channel has a capacity of 30 kbps. The signal to noise ratio of the channel is what we have already discussed in the previous lecture as well, that channel capacity C is equals to bandwidth log base 2 1 plus S by N, that is signal to noise ratio. So we are having here the channel capacity of 30 kbps, 30 into 10 to the power 3, that is equals to bandwidth is 3000 Hz, that is 3 into 10 to the power 3 log base 2 1 plus S by N. So if you see here, this 10 to the power 3 will get cancelled, and if you cancel 30 by 3, then you are going to get 10 here. So 10 is equals to log base 2 1 plus S by N. Therefore you can write 1 plus S by N is equals to, if you take antilog, then as the base is 2, so it is going to be 2 to the power this value 10. 2 to the power 10 is equals to 1024. So SNR, S by N, that is therefore SNR, S by N is equals to 1024 minus 1, that is 1023. So it is the absolute value. It is the absolute value of SNR. If you have to take it in decibel, therefore S by N in dB, to take S by N in dB, you just have to take 10 log of this value, 10 log base 10 of this 1024. And what is the value? If you check, that is log 1023. 1023 is 3.0098 into 10. So it is going to be 30.098. It's going to be 30.098 dB. And the correct option, most appropriate, is option C, that is 30 dB. Next, in differential PCM, each word indicates difference between a sample amplitude and a reference signal is wrong. We have already discussed that in DPCM, the sample is compared with the previous sample. So if you read the options, difference in amplitude between a sample and the previous sample is correct. That's why in DPCM, we just have to encode the difference between two samples, which will require lesser number of bits. Therefore, it will require lesser number of bandwidth. Therefore, this system is sometimes better. So option B is correct in this question. See the next option, next question. Good voice reproduction via PCM requires 128 quantization levels. What you are having is quantization levels, that is L, that is 2 to the power n, that is going to be given to be 128. Therefore, from here you can find n, that is log base 2L, that is equals to what? 7. If you see here, then 2 to the power 7 is equals to 128. So it is n equals to 7. So for this PCM system, every sample is going to be encoded in 7 number of bits. Next, what is given? If bandwidth of voice channel is 10 kilohertz. So for voice channel, it is a low pass signal. Every voice channel, that is a low pass signal, and for its for low pass signal, the maximum frequency component itself is the bandwidth of that signal. Therefore, here as we are having bandwidth is 4 kilohertz, it means maximum frequency component is given to be 4 kilohertz. So if we have to calculate the data rate, that is number of bits transmitted per second, for this you first need to calculate the sampling frequency, and using the Nyquist sampling rate, if FM is equals to 4 kilohertz, then sampling frequency is equals to twice of FM, that is equals to 8 kilohertz. It is also you can use the formula, that is maximum data rate. Maximum data rate, that is equals to nothing but channel capacity. Channel capacity is equals to C is equals to Fs into log 2L. Log 2L. So you can also take it, or at the place of Fs, normally you take twice of FM. 2 FM or 2 BM bandwidth you also take, because FM is equals to nothing but bandwidth. So you take 2B, or you can write it like Fs n into Fs, because it is nothing but n. So it is n into Fs. You can understand it in this way as well, that for PCM systems, in every sampling interval, that is in TS duration, in, if you understand it like this, n bits, or you can write like this, in TS duration, in sampling interval in TS duration, bits to be transmitted is equals to what? N. Therefore in 1 second, if in TS seconds total n bit is to be transmitted, therefore in 1 second n upon TS bit is to be transmitted, and 1 upon TS is equals to Fs, that is equals to NFS. Therefore it is the data rate, and bit rate divided by 2 will give you the bandwidth. खैर चलिए यहाँ पर देखते हैं, यहाँ क्या पूछा गया क्वेश्चन में. हमारे पास सैम्पलिंग फ्रीक्वेंसी हमें पता है 8 किलोहर्ट्ज. कितने बिट्स में एनकोड करना है एक को? 7 बिट्स में. 1 सेकंड में कितने सैंपल्स भेजने की सैम्पलिंग फ्रीक्वेंसी है, मतलब क्या है ये? इट इज नंबर ऑफ सैंपल्स. इट इज नंबर ऑफ सैंपल्स ट्रांसमिटेड पर सेकंड. ट्रांसमिटेड पर सेकंड. ठीक है. और ये n क्या है? इट इज नंबर ऑफ बिट्स पर सैंपल. बिट्स पर सैंपल. तो अगर हम बिट्स पर सैंपल को सैंपल से मल्टीप्लाई कर देंगे सैंपल्स पर सेकंड से, तो हमें क्या पता चलेगा? ये क्या है हमारा? देयरफॉर अगर आप देखें डेटा रेट, तो डेटा रेट इक्वल्स टू क्या कह सकते हैं आप? अगर बिट्स पर सैंपल, इसको अगर हम मल्टीप्लाई कर दें सैंपल्स पर सेकंड से, तो क्या होगा? सैंपल कैंसिल हो जाएगा और आपको क्या मिल जाएगा? बिट्स पर सेकंड मिल जाएगा. यही तो होता है डेटा रेट. यही होता है ना डेटा रेट. तो आपके पास नंबर ऑफ सैंपल्स भी हैं और नंबर ऑफ बिट्स पर सैंपल भी है और सैंपल्स पर सेकेंड भी है, तो इसलिए डेटा रेट इक्वल्स टू व्हाट, बिट्स पर सैंपल इज 7 इंटू, ठीक है, 7 इंटू 8 किलो हर्ट्ज, दैट इज इक्वल्स टू 56 किलो हर्ट्ज, एंड अकॉर्डिंगली ऑप्शन सी इज करेक्ट। ये समझ रहे डेटा रेट। अब यहीं अगर बैंडविड्थ पूछी जाती तो बैंडविड्थ इज व्हाट, डेटा रेट डिवाइडेड बाई 2 करना पड़ता। चलिए नेक्स्ट हम देखते हैं। अ बाइनरी चैनल विद कैपेसिटी 36 kbps इज अवेलेबल फॉर पीसीएम ट्रांसमिशन। क्या बता दिया गया, चैनल कैपेसिटी बता दी गई। अभी अभी हमने क्या बात की, C इज इक्वल्स टू हम क्या लिख सकते हैं, 2b log 2l, ठीक है। तो ये हमें चैनल कैपेसिटी बता दी गई है कितनी, 36 kbps। और क्या बताया गया, इज अवेलेबल फॉर पीसीएम ट्रांसमिशन इफ सिग्नल इज बैंड लिमिटेड टू 3.2 किलोहर्ट्ज। एफएम हमारे पास गिवन है, मैक्सिमम फ्रीक्वेंसी कंपोनेंट ऑफ सिग्नल 3.2 किलोहर्ट्ज। तो अगर ये एफएम है तो एफएस क्या होना चाहिए, मस्ट बी ग्रेटर देन और इक्वल्स टू ट्वाइस ऑफ एफएम, दैट इज एफएस मस्ट बी ग्रेटर देन और इक्वल्स टू 6.4 किलोहर्ट्ज, ठीक है। अब क्या क्या पूछा, देन अप्रोक्सीमेट वैल्यूज ऑफ क्वांटाइजेशन लेवल्स एंड सैम्पलिंग फ्रीक्वेंसी एफएसआर रिस्पेक्टिवली। तो सबसे पहले तो क्या देख लिया हमने, सैम्पलिंग फ्रीक्वेंसी 6.4 से ज़्यादा होनी चाहिए। क्या क्या है ऑप्शन में, 3.6 नहीं हो सकता, 7.2 हो सकता है, 3.6 नहीं हो सकता, 7.2 हो सकता है। तो यहाँ से हम समझ गए, देयरफॉर एफएस इज व्हाट, एफएस फ्रॉम ऑप्शंस हमने सेलेक्ट कर लिया 7.2 किलोहर्ट्ज बाय ऑप्शंस, गिवन ऑप्शंस से हमने ये सेलेक्ट कर लिया, ठीक है। अब अगर ये चीज़ हमें मिल गई, अगर हमें एफएस पता चल गया, तो एफएस इज इक्वल्स टू ट्वाइस ऑफ, यही हम इसको जो लिखते हैं इसको हम ऐसे भी लिख सकते हैं, दैट इज एफएस लॉग बेस टू एल, ठीक है। यहाँ पर आप या तो 2b लिख लें बैंडविड्थ इंटू 2, या उसी को आप क्या लिखें, एफएस लिखें, ठीक है। तो ये एफएस लॉग 2l इज इक्वल्स टू सी। अब सी की वैल्यू पता है, मतलब 36 kbps मतलब 10 to the power 3 इज इक्वल्स टू, एफएस की वैल्यू है कितनी, 7.2 इंटू 10 to the power 3 इंटू लॉग बेस 2l। ये लॉग बेस 2l क्या देगा आपको, यहाँ से आप अगर l कैलकुलेट कर लेंगे तो 2 to the power n इक्वल्स टू l होता है। वहाँ से आपको नंबर ऑफ, अच्छा यहाँ से आपको क्वांटाइजेशन लेवल l ही पूछा गया, तो l पूछा गया तो फिर प्रॉब्लम ही नहीं है, ठीक है। तो देखिए यहाँ से क्या रिजल्ट आ रहा है, यहाँ से अगर हम देखें तो ये कैंसिल हो गया, ये कैंसिल हो गया, और यहाँ 7.2 है, तो आपको दिख रहा है कि लॉग बेस टू l इज इक्वल्स टू 36 अपॉन 7.2, दैट इज ये 5 टाइम्स हो रहा है ना, 5, देयरफॉर l इज इक्वल्स टू 2 to the power 5, log 2l is equals to 5, therefore l is equals to 2 to the power 5, that is equals to what, 32। तो हमारे पास रिजल्ट कितना आ गया, अगर बैंडविड्थ गिवन है तो फिर ये रिजल्ट लेंगे, अगर सैम्पलिंग फ्रीक्वेंसी फाइंड कर ली है तो इस रिजल्ट को यूज करेंगे, ठीक है। तो यहाँ से हमारे पास क्या रिजल्ट आ गया, l इक्वल्स टू 32 नंबर ऑफ क्वांटाइजेशन लेवल्स, या आप कहें ये क्या मिला आपको, log 2 बेस l मतलब ये क्या है, दैट इज इक्वल्स टू n, it is equals to number of bits in which every sample is getting encoded and total number of quantization levels is what, 32। तो उसके अकॉर्डिंग जो ऑप्शन हमारा है वो 32 करेक्ट है, यहाँ से 64 करेक्ट नहीं है, मतलब ऑप्शन डी हमारा करेक्ट। इज इट क्लियर, जल्दी से बता दीजिए। यस, ऑप्शन डी इज करेक्ट, 32 and 7.2 is correct, very good। Next, a comparison of FDM and TDM system shows that FDM requires lower bandwidth but TDM has greater noise immunity। ये बिल्कुल करेक्ट है, TDM has greater noise immunity बिल्कुल करेक्ट है। ये हमने देखा, TDM digital modulation techniques has always greater noise immunity than analog communication। तो TDM में greater noise immunity। अब ये जो ऑप्शन लिखा हुआ है यहाँ पर FDM requires lower bandwidth, अगर हम पर चैनल की बात करें, जैसे मान लीजिए कि अगर हमारे पास ये इतना चैनल, तो TDM में तो ये पूरे का पूरा चैनल एक को देना ही पड़ेगा, क्योंकि एक पर्टिकुलर टाइम के लिए पूरा चैनल किसी एक ही के पास रहता है, भले उसको उतनी रिक्वायरमेंट है या नहीं है। लेकिन एफडीएम में क्या करते हैं हम, अगर हमारे पास इतना चैनल है तो हर एक इंडिविजुअल यूजर को पूरा नहीं देते, हर इंडिविजुअल यूजर के लिए हमें इतनी ही चैनल की जरूरत होती है, इतनी बैंडविड्थ की। तो अगर हम पर यूजर की बात करें, रिक्वायर्स लोअर बैंडविड्थ, हम अगर इसको पर यूजर के अकॉर्डिंग देखें, पर यूजर, तो ये स्टेटमेंट भी करेक्ट है। तो उसके अकॉर्डिंग ये दोनों स्टेटमेंट्स हमारे करेक्ट हो गए। ठीक है, चलिए बाकी ऑप्शंस भी पढ़ लेते हैं। बाकी ऑप्शंस में क्या लिखा है, एफडीएम हैज ग्रेटर नॉइज इम्यूनिटी, बिल्कुल करेक्ट, रॉन्ग है। एफडीएम में बेटर नॉइज इम्यूनिटी नहीं होती, टीडीएम में बेटर नॉइज इम्यूनिटी होती है। ठीक है, नेक्स्ट देखिए, एफडीएम रिक्वायर्स चैनल सिंक्रोनाइजेशन, सिंक्रोनाइजेशन रिक्वायर्स इन टीडीएम, क्योंकि जो हम स्लॉट लेते हैं, इतने स्लॉट के लिए ट्रांसमीटर, जिस टाइम पर स्लॉट पर ट्रांसमीटर एंड पर कनेक्ट हो, उसी टाइम पर हमारा रिसीवर एंड पर भी कनेक्ट होना चाहिए। तो ये कम्यूटेटर ये काम करता है सिंक्रोनाइजेशन के लिए, तो ये टीडीएम में रिक्वायर्ड होता है, एफडीएम में रिक्वायर्ड में नहीं होता। तो ये ऑप्शन भी गलत है। एफडीएम रिक्वायर्स मोर मल्टीप्लेक्सिंग वाइल टीडीएम रिक्वायर्स बैंड पास फिल्टर, बैंड पास फिल्टर्स आर रिक्वायर्ड इन एफडीएम नॉट इन टीडीएम, तो इसलिए ये भी गलत है। तो क्योंकि ये तीन ऑप्शंस में हमें गलत चीजें दिख रही है, इसलिए हम ऑप्शन ए को सेलेक्ट करेंगे और उसके अकॉर्डिंग ऑप्शन ए हमारा करेक्ट है। चलिए नेक्स्ट देखिए, इन टाइम डिवीजन मल्टीप्लेक्सिंग क्रॉस टॉक में बी अवॉइडेड बाय, बार बार हमने क्या बात की थी क्रॉस टॉक में, एडजेसेंट चैनल्स के बीच में इंटरफेरेंस की वजह से क्रॉस टॉक होता है। इसलिए अगर क्रॉस टॉक आ रहा है तो आपको ढूंढना है कि किसी ऑप्शन में पुअर फिल्टरिंग जैसा कुछ लिखा हुआ है क्या। अगर पुअर फिल्टरिंग जैसा ऑप्शन में है तो डेफिनेटली सबसे पहले उसी को हम सेलेक्ट करेंगे। तो प्रॉपर बेस बैंड फिल्टरिंग में भी अवॉइडेड लिखा है, तो हम अगर प्रॉपर बेस बैंड फिल्टरिंग करें तो ये अवॉइड किया जा सकता है और इसलिए डायरेक्टली हम इसको सेलेक्ट कर लेंगे। ठीक है, प्रॉपर सिलेक्शन ऑफ टाइम ऑफ सैम्पलिंग नहीं, हम एडजेसेंट चैनल्स के बीच में इंटरफेरेंस को कम करना चाहते हैं। इंक्रीजिंग एम्पलीट्यूड ऑफ द सिग्नल नहीं, प्रॉपर क्वांटाइजेशन नहीं, मतलब ऑप्शन ए हमारा करेक्ट है। चलिए नेक्स्ट देखिए, अ बाइनरी चैनल विद कैपेसिटी, ये तो क्वेश्चन अभी अभी हमने किया, 32 एंड 7.2, ये तो अभी अभी किया ना, ऑलरेडी डिस्कस्ड। तो ये 2 ईयर्स में आया, अभी देखिए 2013 का है और इसके पहले हमने ये क्वेश्चन किया, वो कब का था, 12 में भी आया, 13 में भी आया, रिपीट हो गया अगले साल। ठीक है, चलिए कोई बात नहीं। नेक्स्ट देखते हैं क्या गिवन है, आउटपुट डेटा रेट ऑफ अ 8-बिट पीसीएम टीडीएम सिस्टम। ठीक है, n इज इक्वल्स टू 8 गिवन है। ठीक है, सैम्पलिंग 24 वॉइस चैनल्स, टोटल नंबर ऑफ चैनल्स कितने हैं, 24 वॉइस चैनल्स हैं, यूजिंग म्यू लॉ एट द रेट ऑफ 8 किलो हर्ट्ज एंड विद अ फ्रेम विद अ वन फ्रेम अलाइनमेंट वर्ड। ओके, देखिए म्यू लॉ हो या ए लॉ हो, ठीक है, अगर हम बिट्स पर फ्रेम की बात करते हैं तो म्यू लॉ या ए लॉ दोनों ही केस में जो बिट्स पर फ्रेम होती है, बिट्स पर फ्रेम इज इक्वल्स टू 8। ठीक है, 8 बिट्स पर फ्रेम और वन फ्रेम अलाइनमेंट वर्ड है। ठीक है, तो देखिए यहाँ पर आपसे क्या पूछा गया, आउटपुट डेटा रेट पूछा गया। सबसे पहले अगर हम इसमें देखें, टोटल 24 वॉइस चैनल्स हैं, हर चैनल 8 बिट पीसीएम सिस्टम को यूज कर रहा है। सैम्पलिंग फ्रीक्वेंसी यहाँ पर fs आपको गिवन है एट द रेट ऑफ 8 किलो हर्ट्ज, fs इज इक्वल्स टू 8 किलो हर्ट्ज। तो अगर हम सबसे पहले देखें कि नंबर ऑफ बिट्स पर चैनल पर सेकेंड, एक सेकेंड में टोटल कितने सैंपल्स आएंगे, जितनी सैम्पलिंग फ्रीक्वेंसी है मतलब 8000, और हर सैंपल को कितने बिट में एनकोड कर रहे हैं हम, 8 बिट में, मतलब कितना हो गया 8 बिट इंटू 8000, दैट इज इक्वल्स टू 64,000। ये समझ रहे हैं क्या लिखा हमने, नंबर ऑफ बिट्स पर चैनल पर सेकेंड, हर एक चैनल एक सेकेंड में कितने बिट्स को ट्रांसमिट कर रहा है, तो हर सैंपल को हमने 8 बिट में एनकोड किया है और fs इज 8000, देयरफॉर 8 इंटू 8000 दैट इज 64,000 बिट्स पर सेकेंड। ठीक है, इतना हमारे पास है। इसके बाद अगर हम देखें यूजिंग म्यू लॉ एट द रेट ऑफ 8 किलो हर्ट्ज, तो बिट्स पर फ्रेम, नंबर ऑफ फ्रेम्स पर सेकेंड कितने हैं, number of frames per second is nothing but sampling frequency, that is 8 kilohertz, that is 8000, ठीक है। and number of, अच्छा ऐसे ऐसे ये जो 64,000 बिट्स पर सेकेंड आया, ऐसे ऐसे हमारे पास कितने हैं टोटल चैनल, देयरफॉर टोटल नंबर ऑफ बिट्स पर सेकेंड इज इक्वल्स टू, ये 64,000 है और ऐसे ऐसे 24 चैनल्स हैं, तो टोटल कितना आ गया, प्लीज वेट, यहाँ तक क्लियर हो रहा है। फ्रॉम वेयर गेट पीडीएफ ऑफ द लेक्चर, तो पीडीएफ आप ये तो मैं अभी शेयर कर दूंगा सर को, आप ऐप से फ्री डाउनलोड सेक्शन में जाकर पीडीएफ्स ले सकते हैं, ठीक है। तो चलिए हम यहाँ पर क्या देख रहे थे, हमने नंबर ऑफ बिट्स पर चैनल देख लिया पहले, फिर टोटल 24 चैनल्स हैं, तो टोटल हमारे पास क्या रिजल्ट आ गया, ये तो हम मल्टीप्लाई कर रहे थे 64,000 इंटू 24, दैट इज 1536,000, ये इतना बिट्स पर सेकेंड हमारे पास आ रहा है, ठीक है। अब हमारे पास कितना है, टोटल 8 बिट्स पर फ्रेम है और हर फ्रेम में सभी हमारे पास टोटल फ्रेम नंबर ऑफ फ्रेम्स पर सेकेंड कितने, 8000। तो अगर आप यहाँ पर देखें कि जो फ्रेम अलाइनमेंट ओवरहेड होगा वो टोटल, अगर हम देखें टोटल फ्रेम अलाइनमेंट ओवरहेड, दैट इज इक्वल्स टू 1 फ्रेम अलाइनमेंट वर्ड, मतलब आपको क्या करना है, यहाँ पर भी 8 बिट्स एक फ्रेम में, तो टोटल नंबर ऑफ फ्रेम्स इज इक्वल्स टू 8000, 8000 फ्रेम्स हैं और हर फ्रेम में 8 वर्ड्स हैं, मतलब यहाँ से कितनी वैल्यू आ गई, 64,000 बिट्स यहाँ से आ गई। तो इसलिए टोटल अगर हमसे डेटा रेट पूछा गया, देयरफॉर आउटपुट डेटा रेट, टोटल आउटपुट डेटा रेट, टोटल आउटपुट डेटा रेट, इट इज इक्वल्स टू, दोनों को बस ऐड कर दीजिए, 15,000 ये 1536,000 एंड प्लस 64,000, दैट इज इक्वल्स टू प्लस 64, इट इज इक्वल्स टू 16,000,000, 16। तो अगर हमसे 10 to the power 6 में गिवन है, तो 1 2 3 4 5 6, मतलब इसको हम क्या लिख सकते हैं, 1.6 इंटू 10 to the power 6 बिट्स पर सेकेंड। उसके अकॉर्डिंग जो ऑप्शन हमारा करेक्ट है वो ये ऑप्शन है। देखिए यहाँ पर हमने क्या किया, टोटल 24 वॉइस चैनल्स हैं, हर एक वॉइस चैनल कितने बिट्स पर सेकेंड ट्रांसमिट कर रहा है, तो टोटल सैम्पलिंग फ्रीक्वेंसी 8 किलोहर्ट्ज, तो एक सेकेंड में 8 किलोहर्ट्ज और हर बिट में टोटल जो जितने भी सैंपल्स हैं, हर सैंपल को हम 8 बिट्स में एनकोड कर रहे हैं, तो हर चैनल पर सेकेंड 64 बिट्स हमारा ट्रांसमिट कर रहा है, ठीक है। ऐसे टोटल 24 चैनल्स हैं, तो टोटल कितने पर सेकेंड में हमें चाहिए, ये इतना तो हमें जो एनकोड जो हमारा सिग्नल ट्रांसमिट हो रहा है वो इतना है। अब इसके अलावा हमें 1 फ्रेम अलाइनमेंट वर्ड भी लेना, तो मतलब 1 फ्रेम अलाइनमेंट मतलब हम यहाँ से अगर म्यू लॉ को कंसिडर करते हैं, तो बिट्स पर फ्रेम कितना होता है म्यू लॉ में, म्यू लॉ होता है ये ए लॉ होता है, दोनों के ही केस में इंडिया में जो यूज होते हैं उन दोनों ही केस में हमारे पास 8 बिट्स ही पर फ्रेम लेना है। अब 8 बिट्स पर फ्रेम है और ऐसे 8000 फ्रेम्स पर सेकेंड है, तो अलाइनमेंट ओवरहेड कितना हो गया, 8000 फ्रेम्स पर सेकेंड, इट इज, मैं यहाँ पर दूसरे कलर से लिख देता हूँ, इट इज फ्रेम्स पर सेकेंड, फ्रेम्स पर सेकेंड, और ये क्या है, बिट्स पर फ्रेम, बिट्स पर फ्रेम। जब आप बिट्स पर फ्रेम को मल्टीप्लाई करेंगे फ्रेम्स पर सेकंड से, तो फ्रेम फ्रेम कैंसिल हो जाएगा और आपको बिट्स पर सेकंड मिलेगा, इसलिए हमारे पास रिजल्ट कितना आ गया, बिट्स पर सेकंड। तो इतना हमारा अलाइनमेंट ओवरहेड है। तो टोटल हमारा पर सेकंड जो हमें बिट ट्रांसमिट करनी है वो कितनी है, इन दोनों का एडिशन। तो इन दोनों के एडिशन से क्या रिजल्ट आ गया, 1.6 इंटू 10⁶ बिट पर सेकंड। उसके अकॉर्डिंग ऑप्शन हमारा सी करेक्ट है। ठीक है, चलिए नेक्स्ट। तो ये आज का लास्ट क्वेश्चन होगा 60 नंबर। 24 वॉइस चैनल्स आर सैम्पल्ड यूजिंग सैम्पल्ड यूनिफॉर्मली एट अ रेट ऑफ 8 किलोहर्ट्ज। सैम्पलिंग फ्रीक्वेंसी दे दी गई 8 किलोहर्ट्ज। क्या पूछा गया, एंड देन टाइम डिवीजन मल्टीप्लेक्स। उसके बाद हमने इसका टीडीएम कर दिया। ठीक है, टीडीएम में क्या करते हैं हम, हर एक यूजर के पास सैम्पलिंग इंटरवल जितना होगा हमारा उस एक सैम्पलिंग इंटरवल के बराबर हर एक यूजर के पास हमारी पूरी बैंडविड्थ रहेगी। ठीक है, तो अगर सैम्पलिंग फ्रीक्वेंसी हमें पता है, मतलब यहां से हम सैम्पलिंग इंटरवल निकाल सकते हैं 1/8 किलोहर्ट्ज, दैट इज 8 इंटू 10⁻³ सेकेंड्स। किलोहर्ट्ज ही है ना, तो ये रिजल्ट कितना आ गया। इसको अगर हम ऐसे लिख लें कि 1000/8 इंटू 10⁻⁻6, ऐसा लिख सकते हैं। ये 10⁻³ ऊपर जाता 10⁻³ हो जाता, 1000 और मल्टीप्लाई कर दिया तो 3 की जगह -6 लिख लिया। अब 1000/8 का मतलब हो गया कितना, 125। तो इसको हम लिख सकते हैं 125 माइक्रोसेकेंड्स। मतलब हर एक यूजर के पास इतने ड्यूरेशन तक हमारे, मतलब टोटल हमारे पास जो ड्यूरेशन है, सैम्पलिंग जो इंटरवल है, एक सैम्पलिंग इंटरवल में सभी का डेटा हमारे पास आ जाना चाहिए। तो हमारे पास इतना टोटल टाइम स्लॉट अवेलेबल है। ठीक है, टोटल टाइम स्लॉट है हमारे पास 125 माइक्रोसेकेंड्स का। ठीक है, टोटल कितने यूजर्स हैं, 24 वॉइस चैनल्स हैं। हर वॉइस चैनल का डेटा एक सैम्पलिंग इंटरवल में हमारे पास कुछ कुछ टाइम स्लॉट हमने बांट दिया है, तो सभी का डेटा हमारे पास इतनी देर में आ जाना चाहिए। अब इसके बाद क्या गिवन है, The sampling process uses flat top samples। ठीक है, फ्लैट टॉप सैंपल्स विथ 1 माइक्रोसेकेंड ड्यूरेशन। हर एक वॉइस चैनल का डेटा के लिए ड्यूरेशन कितना है, ईच डेटा ड्यूरेशन ऑफ ईच चैनल 1 माइक्रोसेकेंड। तो टोटल ड्यूरेशन फॉर 24 चैनल, सभी चैनल का डेटा 1 माइक्रोसेकेंड ड्यूरेशन का है। तो टोटल 24 चैनल्स का टोटल ड्यूरेशन कितना होगा डेटा का, दैट इज 24 इंटू 1 विच इज इक्वल टू 24 माइक्रोसेकेंड्स। अब इसके साथ हम जब भी टीडीएम करते हैं, हमने पहले भी बात की, तो वहां पर एक सिंक्रोनाइजेशन बिट्स पर फ्रेम भेजा जाता है। एक फ्रेम में एक सिंक्रोनाइजेशन बिट्स होती है जो बताती है स्टार्ट ऑफ द फ्रेम कहाँ से। ठीक है, द मल्टीप्लेक्सिंग ऑपरेशन इंक्लूड्स प्रोविजन ऑफ सिंक्रोनाइजेशन बाय एडिंग एन एक्स्ट्रा पल्स ऑफ 1 माइक्रोसेकेंड। ठीक है, तो सिंक्रोनाइजेशन पल्स 1 माइक्रोसेकेंड। तो टोटल हमारे पास ड्यूरेशन कितना आ गया, 25। एक अगर हम सैम्पलिंग इंटरवल में देखें तो हमारे पास क्या करना है, हमें 24 चैनल्स का डेटा लेना है 24 माइक्रोसेकेंड्स का, और एक सिंक्रोनाइजेशन पल्स भी लेनी है कितनी, 1 माइक्रोसेकेंड की। तो देयरफॉर टोटल ड्यूरेशन रिक्वायर्ड पर फ्रेम हमारे पास कितनी ड्यूरेशन रिक्वायर्ड है, दैट इज इक्वल्स टू 24 माइक्रोसेकेंड प्लस 1 माइक्रोसेकेंड, दैट इज इक्वल्स टू 25 माइक्रोसेकेंड। तो अब 25 माइक्रोसेकेंड्स हमारा ड्यूरेशन होना चाहिए। हमारे पास अवेलेबल कितना है, 125 माइक्रोसेकेंड्स। तो अब हम अगर देखें 25 माइक्रोसेकेंड से 125 माइक्रोसेकेंड से मतलब हर एक यूजर के लिए हम कितना स्लॉट दे सकते हैं, देयरफॉर टाइम स्लॉट possible for each user is equals to total available 125 microseconds divided by 5 microseconds, that is equals to by 25 microseconds, that is equals to 5 microseconds। हमारे पास जो फ्रेम है वो 25 माइक्रोसेकेंड्स में कंप्लीट हो रही, ठीक है, और हमारे पास टोटल ड्यूरेशन अवेलेबल है 125 माइक्रोसेकेंड्स का। तो इसका मतलब है कि हर एक वॉइस चैनल के पास कितनी देर तक पूरा चैनल हम रख सकते हैं, दैट इज 5 माइक्रोसेकेंड्स तक। अब हमसे क्या पूछा गया यहाँ पर, द स्पेसिंग बिटवीन सक्सेसिव पल्सेस ऑफ द मल्टीप्लेक्स सिग्नल इज। अब हर चैनल को ये 5 सेकंड तक तो डेटा भेजना नहीं है, सभी चैनल का जो डेटा का ड्यूरेशन है वो 1 ही सेकंड का ड्यूरेशन है। तो 1 सेकंड में अपना डेटा भेज देगा, उसके बाद अगले जो सोर्स का डेटा होगा, अगले वॉइस चैनल का जो डेटा आएगा, तो 1 सेकंड डेटा भेजने के बाद उसके पास कितना रिमेनिंग है, वही क्या है, 2 चैनल्स के बीच में स्पेसिंग है। देयरफॉर अगर हमें स्पेसिंग बिटवीन सक्सेसिव पल्सेस देखना है तो देयरफॉर आप लिख सकते हैं स्पेसिंग बिटवीन सक्सेसिव पल्सेस इज इक्वल्स टू 5 माइक्रोसेकेंड्स तक तो हमारे पास अवेलेबल टाइम स्लॉट है हर पल्स के लिए, हर वॉइस चैनल के लिए, लेकिन हमें डेटा भेजना है सिर्फ 1 ही माइक्रोसेकेंड का। तो इसका मतलब जो रिमेनिंग है वो क्या है, दो एडजेसेंट वॉइस चैनल के बीच में हमारी टाइम स्लॉट की स्पेसिंग है। तो 5 माइक्रोसेकेंड माइनस 1 माइक्रोसेकेंड, दैट इज 4 माइक्रोसेकेंड इज द करेक्ट ऑप्शन फॉर द स्पेसिंग बिटवीन 2 adjacent multiplexed signals. Therefore, the option corresponding which is correct is 4 microsecond is correct. तो ठीक है, तो ये हमारे सारे क्वेश्चंस हो चुके हैं। तो चलिए एक बार बता देंगे मुझे जल्दी से कि क्या आप सभी लोगों को इनमें से किसी भी क्वेश्चन में कोई डाउट है और क्या सारी चीज़ें आप क्लियरली समझ पाए आज के लेक्चर से। सो प्लीज़ लेट मी नो इफ यू हैव any doubts in any of the given questions from, we have solved already 60 questions, so if you are having any doubt then please let me know, and if you are getting benefited by these sessions, then please mention it in comment section and like and share the video, because the new users judges the quality of videos by observing the likes and number of views. So the number of views if you see, then for signals, as the signal is common subject for EEC and IN, therefore signal system videos will get a view almost equals to 1000. But for these communication system videos, because this communication is only for EEC, means for gate it is only for EC, therefore some views will be lesser as compared to signal system. So this video will go into the range of 506 to 600 views. So if you are going to like this video, then new viewers will find it appropriate and will go through these videos. So I hope everything is clear. Very good, Ravi. So should we end the session? If you are not having any doubt, then now we are going to end the session. चलिए तो फिर डाउट्स नहीं है तो आज का सेशन एंड करते हैं और मिलेंगे फिर नेक्स्ट सेशन में। तो तब तक के लिए थैंक यू सो मच, ऑल द बेस्ट, टेक केयर, बाय बाय, थैंक यू।